Yes, ma'am, we can start now.
Yeah.
Sir, I'm starting with the program.
हाँ हमारी सुन ना ये जो टोटल पार्टिसिपेंट है ना उसमें सिद्धार्थ होता
Manish sir.
और गुरु आयरप्पन हो गया हम लोगों के पास कैमरा और माइक एक्सेस नहीं है। मेरा
Yes, Pooja, go on.
Yes, sir.
एक्सेस
A
नहीं
very good morning,
है और
everyone.
एक और नाम है
I'm
गुरु
Pooja Shukla,
आयरप्पन।
Assistant Director with the National Board for Quality Promotion of the Quality Council of India. And I welcome you all to our 22nd Virtual Quality Conclave, which is being jointly hosted by NBQP and PAT Division. Respected speakers and participants, as you all are aware, QCI Quality Conclaves are organized around contemporary themes to help the industry, consumers, and other stakeholders understand challenges and opportunities better and adopt the best practices in quality and technology to strengthen the quality ecosystem. In line with the same, the theme of this conclave is Drone Sector, a Way to Quality. Friends, we are witnessing technology advancement at an unprecedented pace and can say that from the internet to electric vehicles, we might be in the golden age of technology advancement. The world of unmanned aerial vehicles or drone is no exception. The drone space in India is also catching up that in other nations and gaining considerable momentum. And the use has been gradually rising in various applications, whether it is aerial cinematography, land surveys, agricultures and mining activities, or mapping national highways and railway tracks. Recognizing the critical role that the drone sector will play in the coming times, with their applications ranging from civil to defense purposes, the government has been proactively creating a conducive ecosystem through industry-wide reforms, transparency in regulations, and inclusion of drone sector under the PLI scheme with an aim to make the India a drone hub by 2030. To assist in this endeavor, QCI has instituted the certification scheme for unmanned aircraft systems UAS. So friends, in our conclave today, we will witness deliberation on the important aspect of UAS sector, including the role of quality, safety, security, compliance, and the certification in the UAS sector. The deliberation in the conclave today will be witnessed in 4 technical sessions that will begin immediately after the inaugural session. Without taking any more time, let me invite and introduce Dr. Manish Pandey, Director and Head PAT Division, QCI, for the welcome address. An experienced sustainability professional with over 20 years of experience in leadership roles based on a PhD in agroforestry systems, currently Director and Head of Project Analysis and Documentation PAT Division at QCI and nominated Chair NPISC Network UNFSSS, leading flagship governmental and intergovernmental initiatives such as the India National Platform on Private Sustainability Standards, Design and Development for Certification of Scheme RPAS, Drones Dgca, Medicinal Plants NMPB, HRAA, FSSAI Yoga Certification, Nodal for National GLP Compliance Monitoring Authority, previously with leading government and private organization UNCTAD, WWF, SGS, and others. We welcome you, sir. Over to you.
Thank you, Pooja. I think so. I was stopping you because we have very less time. I would straight away formally thank my team for organizing this VQC along with NBQP. The intent of the program is to move the next steps. The first challenge was to get the TC, at least one TC out of our table, which under the guidance of the Joint Secretary, Mr. Ambar Dubey, we have done that. Now the focus of us is to see that we have less or maybe nil rejections. For that, we need the PMU under the leadership of Mr. Shia Sharma to see that forms formats are in place so that we have lesser number of rejects and the CVs more focused towards issuing the TCs. I'll stop here because Pooja, my introduction has taken my slot. So I'll stop here and I would request Mr. Amber Dubey, Joint Secretary, the power and the guiding light on this initiative. Sir, over to you. Dubey sir, is your mic on mute or I don't see him? Let me just call him up.
Sir, I think he's reconnecting. I think.
Yeah, I think so. Yeah.
Ashish sir has joined.
Sir, I'm sharing with you the link. Oh.
Pooja, any idea what is the status of his?
So we cannot see Amber sir in the participant list as well.
Sir, I think he was present there briefly.
Yeah, he was connected earlier.
Yes,
Yes,
and I think he
yes,
has left.
yes.
I'm not
No,
sure.
it is written your mic is disabled.
Yeah,
Uh,
even I read that, sir. But I cannot see him in the participant
So
list.
he has joined.
Yeah.
Okay.
Yes, sir is joined.
Sir, over to you. Sorry for the inconvenience. Oh, he's there.
Any bore you guys with a long speech? Any
Ashish, can you mute your mic, please?
am I audible?
Amber sir, you're not audible. Your voice is
That's
quite
okay.
low.
Uh, can you hear me?
Yes, sir. We can hear you now, sir.
Yes.
Yes, sir.
I'm unfortunately in a bad network area, just stepping into the parliament for a parliament committee meeting. So I'll keep it very short because there's a long session ahead, and I first of all thank QCI for organizing this. The more we talk, this is a new system, and in any new system, there's always that people, that people don't understand. Then they badmouth the system. So the more we talk, the more people will understand, because this is a harsh reality that we have moved from a am I audible? Just drop me and move on. Hello.
So your voice is cracking in between.
What I'll suggest is just the program. Drop me. We'll chat later. Okay. Chalo.
Right, sir. Thank you so much. I think so. What you said, just to encapsulate, because some of these participants could not hear you. So what sir says is that any new program will have its own, what do I say, learning curve. Initially, we will have resistance. There would be some people who would criticize, some would try to pull it down, but there are supporters, and the first TC that has been granted shows that the things were all well thought. Yes, there were some challenges, as we all know that a new system will have challenges. We have some good speakers, including the one who has received his TC, which is the Iotech World, and then very shortly, I think so, we will have the another TC out, which would be from the agreed drone from the surveillance team, which was the crystal ball. We have both the speakers. One will tell you the grit of which they have gone through, and the other will tell that how in a very strategic and methodical way things can be done. So we will have both the extremes talking to you. And with this, I will stop here, and I would request Mr. Sharma to please render a vote of thanks, and then we start the technical sessions. Sharma sir, over to you.
Thank you, Dr. Pandey, for brief insights about the current scenario of CS-US scheme. And thank you, Amber sir, for your brief, I would say, interventions regarding the current status and what are the challenges and how we can cope up with those challenges. And on the behalf of Quality Council of India, I would like to assure MOPA and all the stakeholders that we will continue to enhance our capabilities in terms of effective engagement of stakeholders, to speed up our processes, to scale up our activities in terms of type certificates, and without compromising any quality norms. So thank you very much for sharing your views. And since this is an inaugural session, and thereafter there will be a few sessions which will be addressing technical requirements of certification scheme. So I would request all the participants to please keep your mics and videos in off mode. And if you have any queries or some questions, you can write in the chat box, and our team can take up those queries and questions after the each sessions. Once each session is completed, we'll have some time to discuss on those queries. So thank you very much, Dr. Pandey, and thank you very much, Amber sir, for sparing some time for this conclave. Thank you. Yeah, you would like to add something.
Okay, let me also very happily announce that the other manufacturer, which is the Crystal Ball, has received its TC. I have an email just now. So congratulations and a round of applause for them. They have also joined the club, and my congratulations to Mr. Saib personally also, because I have seen him running around, from Hyderabad to Delhi, and staying Delhi to a time where he could actually show his compliance as would be desired by the DGCA, who has a very high level of, what do I say, standards in terms of checking up the documents. So heartiest congratulations. My gratitude also to the DGCA team, who has been working throughout to see that in a very favorable way to check things, and of course to agree to the SOCs which have been issued both by the UL and the TQ. CS, nothing better. Very good omen. Congratulations to you also to have this VQC, where the second so-called things which were somewhere having some inertia has now moved on. So I think so you have now both the participants having their TC in place. All the best. Over to you, CS.
Thank you. So thank you very much for this, I would say, breaking news and very good news. Now, Pooja, I would request you to continue with the sessions.
Yes, sir. Sir, let me introduce you as a moderator for this session. Mr. C.S. Sharma is serving as a Joint Director in the Project Analysis and Documentation Division, Quality Council of India. He is an electronics and communication engineer and has more than 20 years of varied experience in third-party certification, accreditation, total quality management, auditing, lean management, business excellence, international cyber laws, etc. Mr. Sharma is also an APAC peer evaluator for personal certification for APAC region accreditation bodies. Currently, he is managing various voluntary accreditation and certification schemes under QCI like ICMED, RMCPCS, Ayush, Star Rating, RPAS, etc. Before handing over the forum to Mr. Sharma, let me, during the technical session, in case the participants have any questions, they may type their questions in the chat box along with the same of the with the name of the speaker whom they would like to ask the questions. Questions will be taken up at the end of the respective session. With this, let me welcome Mr. Sharma, and over to you, sir.
Thank you, Pooja. So this particular technical session is the subject and theme of the session is certification process. That how a application form need to be moved in terms of type certification requirements. So I would like to share a brief presentation. Are you able to see my screen?
No, sir.
Okay. Now you can see?
Yes, sir.
Okay, thank you. So here we can see that we represent PAD division, and Quality Council of India was established in 1997 through a cabinet note. I will not go into the details of history, but as far as drones initiatives are concerned, in 2019 we signed an MOU with Dgca to develop a certification scheme for drones in India. And as we understand that in 2021, drone rules were published, and those were basically liberalized drone rules where a lot of complexities were, I would say, dropped out. And the industry, as per the industry requirements, those drone rules were published. And I would say those drone rules are industry friendly in terms of implementation and in terms of policy related requirements. And since 2019, we are working on those requirements pertaining to certification scheme for RPAS or CSUS systems. And in 2021, when drone rules were published, certain requirements were readdressed into the current certification scheme. And in January 2022, 26 Jan 2022, this scheme was notified by MOCA through Gazette notification. And right now, this scheme is published and under operation. And this is a pictorial, I would say, description that how this scheme was designed and developed through effective engagement of various stakeholders. We formed three committees. One was steering committee, then technical committee, and certification committee. And through periodic and regular interaction among different stakeholders and their interventions through different committees which were responsible for different requirements. For example, certification committee was responsible for conformity assessment requirements. Technical committee is responsible for technical requirements and other technical aspects pertaining to certification scheme. So through number of technical deliberations and different formal and informal meetings, the certification scheme was developed, and certification bodies which are integral part of the certification scheme. So those were approved by Quality Council of India to operate this certification scheme. So here we can see that this scheme is being operational through certification bodies, and certification bodies are supposed to issue a statement of conformity, and Dgca is supposed to take final decision on the type certificate. In this slide, a detailed certification process has been highlighted. For example, any manufacturer who's interested in getting type certificate, first they have to understand the scheme requirement, which are being highlighted in the section 3 of the certification scheme. They have to read those requirements, they have to understand those requirements, and then they have to implement those requirements into their current systems. When I say implementation, it means they have to get their documents ready. They have to prepare their manuals. They have to prepare their procedures, work instruction, flight logs, formats, operational manual, maintenance manuals. All those requirements pertaining to documentation need to be completed. At the same time, there are certain testing requirements are being given in the scheme. So it's the responsibility of each and every manufacturer that those testing requirements need to be completed and complied in terms of defined specifications. And once those tests and related documents are being completed, a manufacturer or applicant can apply on DSP platform through D1 application form. Once this D1 application form is being submitted formally through the different evidences of those documents and test reports, a certification body is supposed to take up those D1 forms. A manufacturer has enough freedom to select approved certification body within this D1 format. So right now there are three certification bodies which are being approved by Quality Council of India. So a manufacturer can select any of the approved certification body in the D1 form itself. Once this D1 form is being submitted, a certification body take up the D1 form, and they are supposed to contact the client for further process. And if there are any residue information which is required from the manufacturer, certification body may ask certain additional information from the manufacturers or applicants. Once those information is being furnished by manufacturer, then certification body has to take the decision on the application, whether this application review has been completed or not, or they still require certain information. And if those information are not being furnished properly, then certification body may reject those D1 forms. So within 7 days, a certification body is supposed to take actions on those particular D1 formats and forms, whether they would like to process it further or they would like to ask manufacturer to resubmit the D1 form. Once D1 form is being processed for further stages of SOC, then stage 1 is being planned by certification body. During this stage 1, certification body allocate a team of evaluators or auditors. They are supposed to do a comprehensive review of documentation system of manufacturers. And during this document review, if there are certain gaps, those gaps are being highlighted or identified by certification body. Those gaps need to be closed by applicant within a defined timeline. And once those gaps are being closed, certification body is supposed to plan stage 2. And stage 2 is an on-site assessment where all those technical aspects pertaining to UAVs are being seen formally in terms of physical verification of those requirements. For example, flight test is being witnessed in the stage 2 exercise. So there may be certain gaps in the stage 2 as well, and the applicant is supposed to close those gaps within a defined timeline. And once those gaps are being closed, certification body do a final evaluation of all those findings internally to see whether all those section 3 requirements are being met or not. And once those requirements are being met as per the certification body's internal process and as per the section 3 of technical criteria, then they are supposed to issue a SOC, statement of conformity. Once this statement of conformity is being issued by a certification body, this entire pack of SOC is being submitted to DGCA. DGCA is also independently reviewing all those compliances, conformity assessment requirements, or technical requirements pertaining to certification requirement of the certification scheme independently. And I would like to reiterate that at this stage also, there may be certain gaps which may be identified by DGCA. So those gaps are formally communicated to certification body, and certification body is supposed to take actions on those gaps. And if required, those manufacturer may be contacted again by certification body, and those gaps need to be closed. So there are three stages where gaps may be identified, whether it's a stage 1, stage 2, or when file is with DGCA. So once those gaps are being closed by the manufacturer and certification body, then DGCA is supposed to take a final decision whether a type certificate need to be issued or not. And once DGCA take in decision that yes, now all the gaps are being closed and type certificates can be issued, then DGCA take a decision to issue a type certificate for a particular drone model to a particular manufacturer. And the validity of this certificate is 5 years. And each and every five years, those certificates need to be renewed. So this is the entire certification process which is being defined in the certification scheme. Now, in case if there are certain changes after the certification is being issued to any manufacturer, so in that case, the manufacturer can again reapply those modification in the D1 forms, and they can submit the details in the D1 form itself, that okay, these are the changes, and certification body is supposed to take actions on those modification and changes, and they can define further processes for issuance of revised SOC. And on the basis of that revised SOC, again DGCA is supposed to take a decision that whether a revised type certificate need to be issued on the basis of modified specification or updated specifications. So all these requirements are being again addressed in the certification process, and it's the ownership and responsibility of any applicant or manufacturers that whenever there are any changes in the drone model or certain specification, whether it's a internal specification of frame or battery specifications or payload specification, any type of change in any type of specifications need to be immediately communicated to the certification body, and certification body is supposed to take a review of those changes, and again they have to see that whether additional assessment need to be conducted for issuance of revised type certificate. So this entire exercise is defined in detail in the certification schemes, and if there are any certain queries, I will be happy to take those queries. There are certain initiatives which has been taken by Quality Council of India in recent past. For example, once a scheme was designed and it was approved by DGCA in 2020, and then it was later modifications were done in the scheme, and it was published in 26th Jan 2022. So we are in touch with the stakeholders on a continuous basis, whether it's industry, academia, regulators, or end users. We have a formal system to have a robust feedback and to take cognizance of those inputs, so that our scheme should be in line with those expectations and needs of the different stakeholders. Now, for this purpose also, we are conducting a lot of sensitization workshops and events. And if we see the current status of the scheme, here we can see that first type certificate was issued to Iotech World, and today itself the second type certificate has been issued. Am I audible?
Yes.
Yep. To CBI, and till date we have received total 82 applications, and total SOC issued 2 type certificate issued. There is slight modification in the slide will be there. Two certificate has been issued, and there are total 16 applications are in process. And as far as our certification bodies are concerned, right now we have totally 3 certification bodies are provisionally approved, and we have 6 applications are in pipeline, and those applications are various stages of provisional approval system. And once those are being processed, then definitely there will be a significant increase in the number of approved certification bodies. As a part of spreading awareness, we have conducted total 8 sensitization workshops till date, and including this VQC, we have conducted 2 virtual quality conclaves, and we are also planning a 2-day capacity building technical training program, and this is scheduled on 1st and 2nd July of 2022. And I would request all the participants that if they can nominate certain professionals or experts or auditors or management representatives for these training programs, so that they can have a better idea about understanding of technical requirement of the certification scheme. So this is all about this certification process. And as we know that we have got approved certification bodies certification bodies. So we have got today we have got representation from two certification bodies. One is UL and one is Dgca. So first of all, I would request Mr. Sripam Saurabh to share his views that how this certification body they are operating certification scheme for US system, and what are their challenges, how they are coping up with those challenges, and what are their internal systems by which they are improving on the process requirement in terms of cycle time and in terms of technical capabilities of their personnel who are involved in the certification process. So I would like to invite Mr. Saurabh Sripam. Basically, Sripam is an engineering manager at UL in South Asia and leads a team whose primarily focus is to increase the footprint and develop new services for the fuel cell, energy storage, and EV charges, EV batteries, and drones. So, Mr. Saurabh, are you
Yeah.
there? Yeah,
Yes.
yeah.
Can you hear me?
Yes, yes, I can hear you.
I've shared my screen. Is my screen visible?
Just a minute, yes. Yes, your screen is visible.
Okay, great. Thank you. So, good morning to all the participants, and I would like to thanks QCI for providing this opportunity to make a presentation on our uh, journey so far, uh, the situations in terms of doing the certifications which we are facing, the problems, the goods and the bads. Probably this will help the industry in a long way. Before I start the session and go in depth to it, probably I'll like to talk a little about UL. And UL is basically called as Underwriters Laboratory. Um, this We are more than 128-year-old company, established in 1894. There's an interesting story. That was an era where we have electricity being used by many of the users. Thomas Edison has invented bulb that started going into the consumer house, but then basis on those uses, there were many incidents which were reported, and that's where there were a few deaths, and basis on those risk which the federal government see there, they asked Henry Mineral William, who you can see in the picture, to write the standard and come out with the safety protocols in and around to the systems in order to make the world as a safer place to live in. And that's where we have the birth of UL. Uh, since 1894, we've been founded till 2022. There has been a long journey which we have tried to capture on. We have come out with the first standard in 1902, 1903. But then, as we kept on moving, each decade had certain products coming into the market, and UL has been quite actively working on those developing the standards and then making sure that they comply to those standards in a long run. If I talk about the last 10 or um, 20 years, where we have primarily been focusing, if you see, we have a large concentration on towards the renewable energies, electric vehicles. We have also acquired few companies like Davy, which is purely into the wind certifications. We have a few acquisitions in renewable advisory services, which is AWS Power. We also have a lot of work which we do on a microgrids related. You, Typically, it is more onto the software integrations where you can develop and define the complexities of microgrid and understand how it will operate. And recently, it's like Clear Sky, which is an analytical platform where we are basically doing all kind of artificial intelligence and bringing out the more in-depth data analytics into the running world that cuts across the industry. Just to talk about, we have a two part. One is a non-for-profit, and the other is for the commercial. I basically come from the commercial part. Commercial part deals with all kind of a testing inspection and certifications. We do have a lot of software and advisory services. Whereas on the other hand, the non-for-profit organization is more focused in terms of doing the research on in terms of developing new standards. We also do outreach to the market in terms of educating, in terms of the safeties, the home safety, the fire safety, and all those kind of thing which we try to reach out. So all the commercial aspects where we make revenue ends up in going back to the non-for-profit organization in terms of developing and doing the research activities. If we talk about the industry, I think we have with the length and breadth from all kind of industry. The first column which you see is basically more into a B2B domain industries. So we are helping the customers, and it is more into the industrial applications. So whether we talk about appliance or automotive or mobility, these all are industrial and more into the B2B business. The one which is in the second column is more into the customers who are engaged into B2C. So we are basically touching in all the aspects of industries which we are basically serving right now. We have a global footprint with more than 140 laboratories with more than 14,000 employees working here. In India, we are basically based out in Bangalore, headquartered in Bangalore, and we do have offices in Gurgaon and Mumbai. So with that quick introduction, we'll try to move into the drone certifications. The first one is our journey in US scheme so far. So like CSMA was just presenting the first draft, which has come up in 2021, that's where we got a request from QCI for the initial discussion. And then internally, we started having a sharing of these scheme documents in August 2020, and then internally, which team will do and handle these schemes was decided. I think in October 2020, we basically did the study. Our engineering team and the lab staff did the study of the document, and they started preparing for the NABCB provisional approval, which basically happened in October 2020. And in January 2021, we got the provisional approval. There has been, and even in the previous slides, we have seen that earlier it was called as a ARPA scheme. So there has been a change in ARPA scheme to a US scheme. So basically, there was a transition time from ARPAs to US scheme where basically we also need to change our way of working, and there are a lot of documentations and the requirements which were defined in under ARPA scheme, which kept on changing to ARPAs. But then we kept on working closely with the QCI in terms of these schemes. October 2021, the ownership moved to another business unit, which I'm basically leading on. And then in March 2022 is basically the team has gone through the assessment for the transition from ARPAs to UAS. And from March to May, we have conducted other assessments, including stage 1 and stage 2 for the US scheme, basically which any CB has to go through when they are doing their first certification project. With all this, I think June 2022, we are able to issue the first US project where we issued the SOC. That's a quick background on our journey. Talking a bit about the current status of the application. So we have received almost like 34 applications, and we have a huge amount of rejection. That's a 31 number. Majority of that was booked in terms of in December 2021, whereas the new scheme document came up in 2022, 26 January. The people who applied, the OEMs who applied, um, typically there were many reasons which I'm going to cover why so much of rejections has happened. We have completed the one where we have issued the SOC, and finally that has taken shape to the final certification from Dgca. There are two projects which are in progress right now. So let's talk about what went well here for where we have seen the SOCs, and what has not worked well. That's where we see the large number of rejections. So the completed project which we completed, or even the couple of them which we are working right now. The first and foremost is the responsiveness from the OEM. So they are quite responsive. They are they are easily reachable, and they are also understanding the scheme requirements, more specifically the part 3 of the scheme document, the annexure A, that has to be read by the OEMs, and the definitions, the criterias have been well defined. So we have seen that wherever we have seen the completion, or even where we are working with certain customers, uh, they are they are willing to learn. There are the people who have understood the scheme requirements, and that's the key for them. Also in this journey where we have got a completion, we have seen that there has been a various NCs which we have raised to the OEM, and OEM was acting on those NCs, and they were able to respond to those NCs in a quick succession of time, because we have a cap of 60 days, and this requires a quick response from the OEMs. Where we see the rejections, it is primarily in spite of providing the application forms. There are no responses whatsoever through mail or through phone calls. There is no document details. They basically do provide the certain documents, but those are incomplete documents. And also we felt that majority of this, which actually happened between December 2021 to 2022, before the scheme was officially announced, there were around 20 to 19 to 20 applications which were applied, and basically majority of them has to go for the cancellation because of the understanding of the scheme requirements, and the document requirements. Overall observation is that what we feel is that the requirements which has to come out clearly from the documents. And when we say document, what exactly it is, it's all kind of a manuals. If we are talking about operating manual, maintenance manuals, all those manuals, how it need to look like. There has to be a references from the logbooks. I understand that people are coming from majority of the people in this particular segment are startups, but then we also need to understand that while you are assembling and making your product, QC quality checks become important, and that's where defining and developing the quality documents becomes essential. So that's one observation, which sensitization program like this is certainly going to help, and probably more inputs can be given from the OEMs who are participating today, to see if they would love to see more of such requirements coming up. Second one is the testing requirement from NABL labs. I think QCI has done a wonderful job in terms of putting the links of NABL, and defining that you can search various lab within your close proximities for the respective test. But then still we see that there is not much of awareness in terms of locating which lab can do what. And I think probably we can also build that up into our sensitization program in terms of taking you across the NABL portal, how you can search, how you can find and identify. Another observation is that some tests are optional, but OEM need to decide for overall aspect of product safety. I'll just take this as an example that ingress protection is optional. But then if we are talking about operating these drones in event of rain or any other unavoidable reasons, there can be a the quality of the product can be compromised. So probably I'm seeing a trend where people are seeing that putting the, if it is defined as optional, probably we can opt optional and move on. But then I think just to give you a sense that probably having a bigger vision in terms of having a safer product requires to look into these aspects into a better depth. And the last one, which I want to emphasize, is that before we apply onto the digital platform, uh, preparation has to be done. I mean, we see that people have just applied uh, just for the sake without having the uh, uh, understanding of what all the document needs are and what all the testing requirements are. And when we do so, we have to know that there is just a 60-day period. There are certain tests related to batteries, which goes for especially the BIS certification for the battery itself is a long test. So that requires a preparation from the OEMs in aspect of testing, in aspect of documentation, and in terms of doing demonstrating these tests when the CBs are going to witness. So there has to be a full preparation before we apply onto the digital platform. The next one is what did we learn so far? And since it is a start here in India, and each one of us are learning, and I see that CVs and for us as a great opportunity to learn as well. So the first portion is that I want to touch on is that we have undergone through various assessment through which is done by QCI and Dgca, be it during transition or stage 1 and stage 2. These have been really a great help to us in terms of understanding the scheme requirement as well as the technical aspect. Second one is certification process. So during a certification process, we have learned many things in order to see how we can quickly do the things in terms of keeping the whole time frame of 60 days. Some of the things are listed here, like compiling NCs in one go. Instead of sending you NCs one after the other, we thought to put all the NCs in one go and you respond back all the NCs in one come. That really streamlines the process very well. Stage 2 preparation has to be done in advance. There are various revisions in your internal document which has to be reflected back into your base documents. So those document revisions and all has to be taken care of, and this is a learning for us as well, where we have gone through. Talking a bit about the testing requirements, more specifically on the battery performance test, which was defined, I think we could able to get in more details when we started doing certain projects in terms of how to do these battery performance tests. I think there is a performance related test defined in clause 3.2.1 and 3.2.2, and these clauses defines, and in the normative reference we have a clear picture of IS 16046 part 1 and part 2, which basically defines how to do this test. So we figured out how to do those tests. Second one is on the bench test. I think bench test is used for two purpose. One is for the validation of a design result of a propeller and understand the integrity of propeller and rotor. So probably we have to understand how this bench tests need to be done. So we had a good learning in terms of preparing the benches for doing all this test. Second, this bench test is used to ensure the motor and controller overcurrent protection. So same bench test can be used to simulate the overcurrent protection, overcurrent heating protection while we to ensure onto the motor or motor controller. Third one is on the EMI MC part for the drone itself, where we understand that it need to be done in the turn on conditions, but then we figured out of doing it in a right way in terms of turning it on, removing the blades, tightening the whole setup, and then turning it on and inducing the electromagnetic field to ensure the and to understand the functionality of the product as a whole. The last one is on the field test. There are a lot of field tests which are involved, and we need to have the log of all the. We need to have we need to record all kinds of flight log with respect to all the tests which is being witnessed. Contingency in event of data link loss. This is a little critical one where basically, in order to determine the capability of system to inform the pilot by any means of warning or signal. So there are two ways of doing it. One is GCS is turned off. The second one is taking away the GCS away to extent that it is away from the range, and then we can conduct the test and try to understand whether all the features as defined in the scheme is met or not. So these are the things which we basically learned during the processes, and we are happy to discuss and share more about it, about these learnings to the OEMs as we go progress. So the next one is what next? How is that we are going to enhance our capabilities and technical understandings? So one is we are trying to have in-depth training on drone components and functionalities from all the aspects, more specifically to some of the international standards, which is UL 3030, which is basically for a market access for US market, or ISO 21384, which is for the other countries. Typically, I understand for the customers, after gaining a momentum in Indian market, for them it will be a good opportunity to also outsource their product to other international markets. So we want to ensure that the people and the staff who are working there should start enhancing their technical capabilities into the aspect which can help our Indian OEMs from the broader aspect. The second one is in terms of developing a compliance checklist in terms of incorporating alternate components. Like Sama says, sir said, that the rules are there, but then probably we have to strengthen those rules and see how we what all the combination can lead what kind of a test. So probably those formalizations is something which we would be incorporating and working closely to do that. The last one is for the suggestions for the OEMs. I have split in three parts. The first one is the testing. Before you apply for your application, you have to ensure that you get your battery test done, which is apart from the BIS R number, there's a performance test which is 3.2.1 and 3.2.2 actually conducted before you apply. And the second one is all the applicable tests which are defined in clause 9. Clause 9 is talking about all the performance, all the testing requirements clearly. So we need to ensure that before you apply, the testing part has to be done. The second one is documentation. The best way to do the documentation is you have to take out the CRM document. In fact, we do have developed the CRM document, which is in line to the Annexure A of part 3 of the scheme document. And we have to, I think OEM has to start filling those details in terms of understanding how well or how close they are in terms of a documentation. Second one, which I want to highlight, is that while you are filling a D1 form, you need to ensure that you are filling the information correctly, because in order, if in case you have some issues, then probably we don't have a option of editing those things. Probably it may lead, if the informations are quite unfavorable or drastically it is missing, then probably it may lead to the cancellation of request, and probably that may delay the whole process. So utmost care has to be taken care while OEMs are filling the form, D1 form on the DSP. The last one is on the processes. So while you are engaged with the CBs for the next 60 days, the CB is going to work on your project, and they are going to give the NCs in case if they find that things are not compliant as per the clauses. I think you need to have a discipline which has to be created within the team which is working from your side and interacting with the CBs, that you resolve those NCs within a 24 to 48 hour time zone, ensuring that ensuring these things will ensure that you have a shorter turnaround time, and probably you will able to meet those 60 days time frame. Another one is the QC checks at manufacturing and assembling processes. I think I mentioned and touched this point in the previous slide. Since you guys, most of you are the startups, but you have to understand, for any manufacturing or assembling process, there has to be a quality checks, and those processes has to be well defined. It is not just for the certification purview, but overall from the final product which comes out from your factories in a days to come, and even after you get the certification. So it is quite essential that we take care of of these process requirement. So with that, I think I'm end of the slide. I want to pass on, or if we have any questions, we can take the questions.
Thank you, Saurabh, for such a detailed presentation, where you have highlighted the various practical aspects pertaining to processing of those given forms in terms of certification process. What are the challenges you have faced earlier in time, and what are your course correction measures in terms of your internal systems and processes? But at the same time, you have certain guidelines and expectations from applicants as well, which you have tried to communicate. I think you have quite justified the topic which we have discussing right now. So now I would like to invite Mr. Venugopal B. He is Assistant General Manager in TQ, and more than 30 years of strong background in formulating, implementing, and assessing efficacy of comprehensive quality, safety, loss prevention, environmental and social accountability and strategies, policies and programs ensuring compliance with all applicable local, state, national, and international regulations and guidelines. So, Mr. Venugopal, are you there?
Yeah, sir. I think I am Venugopal.
Yeah. Please continue.
Yeah. Yeah, I think I'm just brief about me. I think what I have said, I think I have more than 30 years of experience in quality certification. Earlier, I was with the Tata Process past 10 years. Previously, I was with Bureau Veritas. Okay. And I'm into this mostly in EPC and the certification processes. Yeah. We have also, I think I'm happy to note that today our first TC also has been issued in this drone certification. I have a brief presentation. I'm sharing my screen. Yeah, just. Morning, sir. Everyone is able to see my screen?
Yes, we can see that.
Yeah. Just a minute. I think yeah. So TQSET is a subsidiary of Tata Projects and a Tata Group company. We are into many sectors. I think we have around our presence is in around 100 countries with 150 products across various countries, and our total revenue 110 billion. I think we are Tata is well known everywhere, multinational company involving in metals, IT, infra, and other sectors. Tata, we are a wholly owned subsidiary of Tata Projects Limited, where we are having four verticals: industrial systems, core infrastructure, urban infrastructure, and services. We form a part of the quality services group, where quality, reliability, utility services, construction tech services, and sustainability solutions we provide to our various clients. Okay. Yeah. So our presence is across the globe. We are present in 40 countries, and in India we have operations in various locations. These are all various approvals we have. Until we are into government, private, and public sectors having QCA. I'll call you. Yeah, QCA. We are approved by QCA, NABCB, PNJRB, Warehouse Development Regulatory Authority, yeah, APIDA, yoga certification. We are enrolled food safety. So these are all some of our approvals which we are having in various sectors. Okay. So across India, we have our project offices as well as local offices. This is our pan-India presence. Coming to US certification, the US certification scheme, I would just, I'm okay. Basically, this is the, I think it's visible now, or should I? Yeah, this is the total process of our certification. Are you able to see, sir? US certification process has CSR Sharma also has already shared with you. The process is same for both the certification. You receive a D1 form, and once the D1 form is received, it application reviews carried out, then application review comments are shared with the client organization, and once they submit the corrective action, we go in for stage 1 and stage 2, which doesn't differ because that is a standard process for both the CBs. Okay, yeah. So as of now, we have received around 40 applications. Out of that, 34 applications got rejected. 9 are in process. One SOC is issued, and another 9 are in work in progress. Okay. Few challenges that we received during the things is a bit stage 1 and stage 2. Normally, what we prefer all the OEMs to be more careful about is in the evaluation. They mostly stage 1 up to stage 1. It is purely on document adequacy of the document that are there with the organization. So mostly what we have seen during our certification process is that most of the documents that are submitted are uncontrolled. Sometimes the same document renamed as a maintenance manual, maintenance inspection schedule, flight schedule, and uploaded. That is one thing that all the OEMs have to be little bit more careful. Generally, what happens, most of the documents undated, no revision status, nothing is there. And every time when we ask any revision is also done, that revision status also is not being appropriately documented. So that is the another thing that we have observed, and this has taken a lot of time in so many iterations and resubmission of the documents. So this is what basically. If they are at the time of the submission itself, the OEMs are, if they are very careful enough to look into all these aspects, there will be less time or less turnaround time in looking at the documents and going to the next stage. Yeah, mostly these are all some of the documents. Mostly what we have seen is that whatever the documentation they are having, they are simply uploading it. So these are the few documents which are mandatory documents which any OEM has to make note of it and submit along with during the D1 uploading process. Technical manuals. Most of the technical manuals, what we have seen is that simply it only gives the description, but no specifications are also there. So this is one more thing where OEMs have to be more educated or more training on these things have to be. I think they have to be more careful when they are preparing this and provide the required information. That's what basically. Flight manual, specification of UAS, general explanation. These are some of the things that are missing in the flight manual. They simply put, and they will say that it should be take off and land, and directly go to the action mode. So without giving any proper specification of what is required. RPA logs. So, operation as well as maintenance logs, they are missing, or they only give a template or format, but whatever they have already completed, that there has to be already records of those things are not uploaded. A maintenance manual also, they don't have what is the for each client may be having different models of the UAS. I think for a specific, it is generic are there, certain are specific. These differentiation is not brought into the maintenance manual. Design information, I think what are the design basis also, I think a few of the manuals it is missing. What are the considerations, design inputs and design outputs? These are all missing in their documents. Analysis reports, I think all and sundry reports which are there, they are simply uploading it without having a specific or a traceability to the requirement that are there as per the regulations. Test procedures, I think this is one area where OEMs have to be very, I think they have to be very extensively, they have to work on this, because test procedures for the analysis, what are the tests and what are the methodology that are they involved in the testing, are they are silent on that, or no traceability is given to them. Test reports, I think test parameters one thing, and the test reports, we have seen that differentiation also. That is one more thing that OEMs have to be, whatever the tests that are required for the same thing. The test reports have to be traceable to the tests that are required. Detailed drawings, hardware, software issues. And every manual, what we normally see is that this is the generic point. This would help us to navigate around the manual very easily. We are missing all these general points. There is no title, no volume, version control is not there. What is the index content? Which page, what is addressing? They're simply putting as a around 100, 150 pages document and uploading it. So then it is very difficult when we review it. It is very difficult to navigate through the document. That's what one more thing which I have observed. Okay. Just a minute. Yeah, stage two, I think this is what basically on site, what all needs to be verified. Those things they have to keep ready. Okay. And see, I think in the clause it is clearly written to be physically verified, to be witnessed. Okay. A few of the, I think these are few observations which we have received in stage one as well as stage two during the review of DGCA. So MTOW mentioned is not matching with the. So basically, this is what we are coming across. In one manual, range is mentioned, in maintenance manual, range is mentioned as something X. In the other manual, it is mentioned as X plus Y. So this is what actually each manual is a standalone or ad hoc manual that we have observed that, and that has so many iterations have taken to correct it. So the time delay has happened because of that. Okay. Yeah, and every time any review is being conducted, they are preparing for the corrective actions only prescribed to that, but they are not again globally incorporating in all the other documents. That is also one more observation that we have seen in our review of the document. Yeah. Each documentation class, I think in that also some review point is brought in one document that has to be replicated in all the areas wherever that is mentioned. Just like example, range is mentioned. It may be mentioned in flight manual. It may be mentioned in maintenance manual. It may be mentioned in the information brochure that you are sending it. But if you are correcting in one document, it is not replicated in the other document. That is also one of the observation that we have seen. And sometimes, no, the abbreviations and definitions also not clearly defined. That is one thing that we have observed in our reviews. A few documents, mostly this we see, most documents are all uncontrolled. No date is there, and no revision issue status, and in the there is no content page is also there. So these are all few observations that we have actually found out during the review of our documents. Thank you. Any questions, sir? Thank you all.
Thank you. Yeah, thank you, Mr. Venugopal. I suppose this was a nice presentation where you could tell us the challenges faced by your certification body and what are the certain areas where applicants may, I would say, furnish systematic information in terms of D1 forms and supportive documents and test report so that cycle time can be reduced further. Because in both the, I would say, presentation, I could see that there are certain cases where there are a lot of iteration of information between applicant and certification body. And most of the time it is related to linkage of certain specification or linkage and version of certain documents. So such type of, I suppose, gaps can be avoided in future. So it may be a good learning for all the stakeholders, including manufacturers and applicants, that whenever they are submitting their D1 forms or whenever they are furnishing the information with respect to documents, flight manuals, maintenance manuals, or certain other aspects with respect to technical specification, whether this is the CG limit or the battery test report. So all those need to be done in a systematic way. And before finally applying to this DSP portal for in terms of D1 form, if all the information and required documents are furnished well before that submission or well before that final submission of D1 form, it would be a great relief to both manufacturer and certification body. So that is the expectation, I think, which we can draw from this discussion. Now, if we have any query, then we can discuss. So, Marshall, can you help that if there are any questions in chat box, which we can take up?
Sure, sir. Sir, actually, there is one question. How we can cover a 0.7 if we use K3A Pro? So we need a elaboration of the 0.7 and a K. It's a specification K3A Pro. Later on, if we share, we will answer later on. Second, there is a thing asking about the checklist. It will be updated on our website by the end of the day. So, am I audible, sir?
Yeah, you're audible. So which checklist you're talking about?
Sir, a person is asking about a checklist for certification.
Okay.
That is what we share with Dgca, means CB shared with Dgca, sir, the final checklist.
Okay. So same we can, I suppose, publish on our website as well. And it will give applicants more, I would say, documented information in terms of what are the compliances in terms of specific documents they have to comply with. I suppose Mr. Danish Gohri is raising his hand. I would request you if you can type your questions or queries in chat box. That would be really great.
Vijay, sir, the PPT will be shared shortly, means after the conclave, we'll share this PPT. Kindly drop your email address in a chat box.
So whatever the information which we are discussing right now, the gist of those final outcomes will be definitely shared by QCI through different means. It's not about PPT only. So certain information may be reflected in FAQs, and we have a set of detailed FAQs which is being published on QCI website, and it is being regularly updated. I will also request you to please go through those FAQs as well, and whatever the outcomes of this particular conclave is there, and important technical discussions are there, then those will be also reflected either in FAQs or in certain other documents later on as well.
Q&A 10 मिनट का ही रखना, 10 मिनट से 1 मिनट भी ऊपर होगा ना, आप आगे बढ़ जाएंगे, पूछते रहें.
So Marshall, can we have any other query?
One more question.
Sir, no other queries in this session. So may continue with the other session, please. Can we move forward?
Okay, okay, fine.
Thank you, sir.
So what I would request that this session is completed. If there are any residue queries, those will be definitely answered. And you have got also flexibility that if there are any further queries or questions or some clarifications are required, you can always write to CSRPAS, our official email ID, and you can talk to anybody or any young professional which are being posted in the PMU. Over to Pooja.
Thank you, sir. With this, we come to the close of our first session, and I would like to thank the moderator, Mr. Sharma, and the speakers, Mr. Sriprant Saurabh and Mr. Venugopal, for this insightful session. Continuing the deliberations, we now move on to our second session, that is certification scheme for unmanned aircraft system. To take this session forward, I would like to welcome and introduce the moderator of this session, Mr. Smith Shah, President, Drone Federation of India. Mr. Shah, currently based in New Delhi, India, holds a bachelor's degree in engineering from the Mumbai University and started his career as a software developer with Germin8, a social intelligence company, to build SaaS-based data analytics products. Passionate about leveraging the power of the healthcare data, he co-founded Check App, a health tech startup, which created an interoperable healthcare data exchange protocol for on-demand access to clinical data across different healthcare service providers. His work also involved interacting with state governments to integrate healthcare data exchange with public health policies. So let me welcome Mr. Shah to take the session ahead. Over to you, Mr. Shah.
Hi, good morning. I hope I'm audible.
Yes, you're audible, sir.
Thank you so much for having me over. Without wasting too much time, let me introduce the technical session 2, which is certification scheme for unmanned aircraft systems. For this session, we are going to have two speakers, Mr. Razak and Mr. Kuldeep Singh Rana. I hope both of you have joined in. I'll introduce the first speaker and then request him to share his session details. Mr. Razak is the General Manager Quality Assurance at HAL and has an aerospace a professional with experience of about 37 years in aviation. He also has an exposure to aircraft manufacturing, quality management, supply chain, export businesses, and corporate management. And he retired as the General Manager Quality Assurance at the from the corporate office at HAL in 2018. He had been in the quality management function of HAL for 31 years. During his initial tenure of over 2 decades at the aircraft division in the Bangalore office, he was responsible for creating and implementing a quality management system which fulfilled the requirements of international aerospace companies like Airbus, Boeing, Israel Aerospace Industries, and various other regulatory authorities such as FAA, CAI, NADCAP, Dgca, CEMILAC, and Dgca. And Mr. Razak is going to be presenting on the criterias for general criteria, performance criteria, power plant, structure, and material and construction. I would want to request Mr. Razak to take the session forward, please.
Yeah, good morning, everyone. Thanks, Mr. Smith Shah. Am I audible?
Yes, sir, you are audible.
Okay, are you able to see my screen?
Yes, definitely.
Yeah, thank you. So today's session for me is, compliance on the factors to tell you is 5 parameters, that is general requirements, performance, power plant, structure, material, and construction. So I would be speaking on these 5 topics. I'll try to explain to the participants what are the basic and the mandatory requirements that are necessary in these 5 topics. Okay. So to start with general. So when we look at general, the most important things what we have to ensure is the first one being the classification of RPAS. So people have to understand very clearly. So what is the classification where they are going to put their RPAS? So the definitions are very clear given in the Dgca manual as well as the certification scheme. So a RPAS which is less than or equal to 250 grams is a nano, and which is greater than 250 grams and less than or equal to 2 kgs is micro, and those which are greater than 2 kgs and less than or equal to 25 kgs are grouped under small category. And similarly, greater than 25 kgs and less than or equal to 150 kg are grouped as medium. Anything that is greater than 150 will be classified as large. So during design, so the manufacturers first what is the classification of their product. So basically by the weight of the product, so that need to be design as well as when verification happens. So it has to be demonstrated through actual weight of the. Then category. So as far as category is concerned, so you need to define what it is, whether it is an aeroplane, rotorcraft, or is a hybrid combination of aeroplane and rotorcraft, or an autonomous. So the category is a type of RP. It is an RPAS. Okay. Next is into the weight. So this is demonstrated. Okay, weight without fuel, battery, and without payload. Similarly, weight with integrated engine, battery, but no fuel or payload. So these things have to be, actually measured and recorded. The same thing will be verified, during the certification, whether these parameters what have been recorded are same or not. You need to demonstrate once again the visiting team. Then maximum all-up weight. Similarly, weight with the maximum largest battery and with all compatible loads, fixed and variable, also need to be recorded. Then the next parameter in general is dimensions. So the most important being the wingspan, maximum diagonal length. This need to be, calculated in design review as well as actual measurement is necessary. You need to record this actual measurement. So only here you need to ensure that whatever the instruments, measuring instruments you use.
Rajak sir, may I intervene? Rajak sir, may I intervene for a while? Rajak sir, actually your voice is breaking. So can we improve a bit on this connectivity if possible?
Okay.
Yeah. If that can be done, yeah.
So as far as the dimensions are concerned, most important span, the maximum diagonal. This need to be calculated during the design review as well as actual measurements need to be made. Here you need to ensure that the instruments that you use for measurements, okay, have to be have a valid calibration from the NABL approved laboratory. The last in general is life of RPM. So here you need to define by design review what is the life of the airframe, life of the engine or battery, and the propeller or rotor, number of maximum permissible landings that you are permitting. This basically has to be done during the design stage itself, and by design review it has to be. This is what our RPAS is going to be. The next topic is the performance. So under performance, so the first one being the speed. Here we need to determine what is the maximum operating speed, what is the maximum minimum operating speed, what is the maximum kinetic energy on impact. Okay, does not exceed 95 kg at any combination of mass and speed. These three parameters are very important, and these need to be demonstrated by actual test and supported by analysis. So this is very important. The next parameter is the range. So here you need to determine what is the maximum range in still air your product will have. This also need to be demonstrated by actual test and supported by analysis. Endurance. Determine fuel and oil consumption, rate of discharge of battery. These two parameters, and this also need to be during actual test as well as supported by analysis. An operational altitude, determine maximum attainable altitude that your drone or RPAS will have. And similarly, this need to be demonstrated during actual test and supported by analysis. Then another parameter is the operational envelope. So here we need to determine the boundaries of operational envelope within which safe flight in normal and emergency conditions can be demonstrated under combination of weight, center of gravity, altitude, temperature, airspeed. So this has to be done during the design and has to be demonstrated by actual test. The next we move on to remaining items under performance is the ceiling height. So we need to determine what is the ceiling height over a range of weight, center of gravity, altitude, temperature, and airspeed. This need to be demonstrated by actual test and as well as supported by analysis. Propeller speed, next parameter is propeller speed and pitch for safe operation. Here we need to determine what is the propeller speed and pitch limits that ensure safe operation under normal operating conditions and integrate the propeller and its mounting at maximum RPM. This parameter also need to be demonstrated and supported by analysis. Stability control. So here we need to determine that RPA is able to maintain a stable flight with pilot able to control RPA with ease. So these two parameters also need to be demonstrated by actual test and supported by analysis. So now let's move on to the next subtopic, power plant. So here power plant could be either an engine or it may be a battery operated. I'll be able to tell you some necessary components for the power plant. As for battery, I think there are two sessions subsequently. You will be able to get more information from other speakers. So engine operated, we need to determine that fan blade can withstand ultimate load of 1.5 times the centrifugal force resulting from operation. Engine, second parameter is engine installation is such it prevents excessive vibration from any part. And then we need to ensure that exhaust is firmly mounted to the structure and free from any obstruction. Okay, this is very important. There is no fuel leak in the system under pressure during operational test on ground. And all these parameters have to be demonstrated by actual test. So the next topic is on structures. So as far as the structures is concerned, the first element that is essential for compliance is strength requirement. So here we need to demonstrate that airframe structure is able to withstand flight limit loads without failure, malfunction, or permanent deformation. So these things, the means of compliance for this would be static test to limit load based on maximum all-up weight, usual check on engine mounting and structure after the test for deformation if any. So these two compliances have to be shown. Then the next one is provide analysis of the structure showing that a factor of safety of 1.5 has been used. So this need to be demonstrated by analysis. So during the design itself, the manufacturers have to take this into consideration. Then another parameter is determine that each removable bolt, screw, nut, pin or other fastener whose loss could jeopardize the safe operation of the RPAS shall incorporate a locking device. So this need to be thought of during the design. So whether such things are there and if at all it is there, so we need to introduce appropriate locking devices. All critical bolts of main load carrying structures to be tightened using a lock nut. All bolts to be locked using a thread locking compound. So these are all the means of compliance that you can do. Okay, another one is to ensure that every bolt has at least 2 threads sticking out of the nut, not applicable for self-locking nut. So these things can be very easily, implemented. The next requirement in the strength parameter is determine that RPA is free from excessive vibrations under any operational speed and power condition. This can only be demonstrated by actual test. Determine that propeller blade clearance is sufficient from structure and or components and from ground. So this need to be verified during the design review itself and also to be demonstrated by actual test. So these are the parameters as far as the strength is concerned. So the next parameter is the shock absorbing mechanism of RPA if applicable. So under this, the first one is it must be shown that the limit load factor selected for design will not be exceeded. This is to be demonstrated by actual test or by analysis. The next being the landing gear may not fail but may yield in a test showing its reserved energy absorption capacity. This also need to be demonstrated by free drop test of the product by itself. So the fifth and the last element that is there for compliance is under this category is material and construction. So type of material for construction, the type of material that we choose for construction, okay. So here the compliance criteria are suitability and durability of materials used for parts, failure of which could adversely affect safety, must be established on the basis of experience or test, must meet approved specifications which will ensure strength and other properties assumed in design data are correct. And third one is take into account the effect of environmental conditions such as temperature and humidity expected in service. So these parameters have to be, the means of compliance is by design review or analysis. Through the design, it has to be, proved that these parameters are in compliance. So here you need to ensure that you maintain material test reports from a NABL approved lab as evidence, or at least original manufacturer's certificate of conformance and certificate of test. If you have purchased a material, if the original manufacturer himself is able to give a certificate as well as give a test report, even that should suffice. If in the absence of that, you have to get the material tested in a NABL approved laboratory and maintain that test report in your records. Material fabrication method. So here the criteria are methods of fabrication used must produce consistently sound structure. So it is very important to choose what fabrication methods we are going to use during the prototype stage, during the design stage itself, because the same processes we are going to use during the serial production. So that's where this point has to be kept in mind, that which processes we are going to use, they must be in a position to consistently produce sound structures. Second parameter is if a fabrication process such as gluing, spot welding, heat treating, etc. If these processes are being used, so we need to ensure that these processes require close control. Okay, by default, these processes in aviation industry are called as special processes, where the infrastructure, the facilities, the people, and the process, everything needs to be controlled. So such processes must have close control. The process must be performed according to an approved process specification. So while utilizing such processes, so we should also ensure that we use a approved process specification to carry out such processes. And this also need to be, the means of compliance is by design review or analysis. The next is fabrication method. So this fabrication method also Okay, we need to decide during the design review itself, and we need to, provide a test specimen to, demonstrate that the fabrication method has not yielded any, adverse effects. So the next parameter under material and construction is means of protection. This is very important. Means of protection and against deterioration or loss of strength in operation due to any cause, that is weathering, corrosion, or abrasion. So here we need to ensure two parameters. The compliance criteria are effect of in-service wear on the loading of critical components should be determined. So this need to be done by design review or analysis, and also followed by a flight or ground test. This is a very important parameter. Then effect of temperature and moisture should be determined in computing material design values. So here the means of compliance would be by design review or analysis, as material strength properties of such certain materials such as composites and adhesives are significantly affected by temperature and moisture. So the manufacturers have to keep this point in their mind. So while designing the product, if we are using a composite material or an adhesive, so we need to be very careful about such materials because they significantly get affected due to temperature and moisture. And another point is we need to use a fire resistant identification plate on RPAS for inscribing the UIN number. So here two things you have to comply. The first one is determination of identification plate material which should be fire resistant. This has to be done during the design stage itself. If and decide what material we are going to use, which is fire resistant. Secondly is we to determine a location of the ID plate along with its secure fixing on the RPAS. And this need to be, documented on the drawing, because this will be verified, during the compliance. This also need to be done during the design review. So these are the 5 topics that I had to explain to you today. So apart from this, I would like to give certain hints that which we have learned during the assessments of various manufacturers, both during stage 1 as well as stage 2 on-site assessments. The first one, what is expected from the manufacturers is that we will look for an overview of compliance to company's quality management system. As a manufacturer, the company should have a defined quality management system. Okay, companies can use their own documented quality management system in reference to any international standards such as ISO 9001 or AS 9100. However, third-party certification is not a requirement at present. Only you need to, take the best practices of one of these two systems and put it into practice, and you can document your own quality management system. Then the second one is knowledge of regulatory requirements, UAE certification scheme, manufacturing and related functions. This is a very important parameter for the entire staff engaged in this manufacturing of RPAS must be aware of these things. So some of these references which I could tell you, and you can easily access these things also. And I suggest you people must go through these documents. It will enhance a lot of knowledge on you as far as understanding the regulatory requirements and certification scheme requirements. The first one is the car series civil aviation requirement section 3 series 10 part 1. And second one is the DGCA RPAS guidance manual. So these are available on DGCA website. Easily you can download. Only thing is you need to be careful, as and when there are changes in that, you need to keep a watch as to whether you are using the current document. That is very, very important. The third one is the certification scheme for UAS. The fourth one is FAQs for UAS scheme 2022. and details of NABL accredited labs. So serial number 3 to 5 are available on QCI website. You can easily download or you can review, look into these things any point of time. Here also, I only caution that you need to keep be cautious about, okay, there could be some changes. So you need to keep a track and understand documents, what you are holding or what you are using are the most current. It should not happen that you try to use a lower issue or an obsolete document and then later on get into problem when your product is manufactured and you want to get it certified. Okay. So the next thing what we expect is that you maintain necessary records such as inspection and test reports, process records, design analysis reports, etc., as evidence of compliance. This is very, very important. See, once the product has been manufactured, okay, product is there one side that can be verified, but it's only document and your test reports that
I think Mr. Rajak has lost his connectivity.
Congratulations so much, sir, and thank you so much for coming to the video. Okay, thank you so much.
Yeah, Mr. Rajak, are you there?
Drop that.
Sir, I think he's rejoining.
Okay, fine.
Answer till Razak sir is joining. I would like to give an answer of a few queries.
Yes, I think, Marshall, you can do that with the permission of moderator, Mr. Smith Shah.
Smith Shah, sir.
Yes, please go ahead.
Thank you. Sir, there is a question about how to determine the life of airframe. So the static test to the limit load is a basic requirement of our scheme, which means the compliance is static load test report. Calculate the maximum flight load and initially estimate of a structural strength. Appropriate software or FEE analysis can be used for the same. So this can be FEA analysis of a life to determine the life of airframe must be sufficient. Coming to the second query, someone asked, explain a bit details about operational envelope. A operational envelope is related to the boundary condition of the flight. So with reference to an combination of all up weight, center of gravity, altitude, temperature, and airspeed. In a simple language, operational envelope is defined by the manufacturer that at which height and boundary condition their drone will be function.
So, Marshall, I think we can see that if Rajak sir has joined, that is fine. Otherwise,
Yes,
I would request Mr. Shah to proceed with the other second speaker.
Not able to locate Razak sir yet.
So, okay, sir. So, what we can do that we can go ahead with our plan, and meanwhile, we will, if he rejoins, then we will see that if he has some residue to share, then he can share.
All right. So we'll invite the next speaker. The next speaker is Dr. Kuldeep Singh Rana from the Central Power Research Institute. He's been working as a scientific officer in CPRI and is involved in R&D, testing and certification activities of energy storage materials and devices. He's also assisted in drafting the series guidelines for battery testing, implementation of the Ministry of New and Renewable Energy Quality Control Order 2017, and has assisted in drafting the energy storage policy with the Ministry of Power, energy efficiency program for high energy lithium-ion traction battery packs. He also worked with Bureau of Energy Efficiency and Niti Aayog for advanced cell chemistry. Dr. Rana is the principal member of CPRI on various committees of BIS, which is notably ETD, TED 11 and 51, and assisting in standard for batteries as well. Dr. Kuldeep Rana will be speaking on the battery-related compliance issues. I would want to request Dr. Kuldeep Rana to begin his session, please.
Yeah, I'm audible, or my
Yes.
PPT is visible? Yeah.
Yes.
So, good morning or good afternoon, all of you. So, thank you for Quality Council of India for inviting me to give a small talk about that battery-related issue, mostly the technical things about the battery-related testing and the compliances. So, I will be speaking about that the compliance, and before that, I will just speak about that requirement for the batteries and what type of batteries are suitable for the UAV applications. So before going to that, I just want to brief about our institute. The CPRI is powerhouse of Indian electrical industry, so which was set up in 1960, and it functions as a center for the applied research and electrical power engineering, assisting electrical industry in product development and quality assurances. So that our battery testing laboratory comes under Electrical Appliance Technology Division of CPRI. So we are doing the testing of the batteries irrespective of any chemistry, and for all application in energy storage, electric vehicle application, and railway and other applications. So our laboratory is accredited by Enable as per ISO IEC 17025, and currently that more than 29 standards are accredited by the different standard, including IEC, Indian standard, Japanese standard, and railway standard by Enable. So yeah, so laboratory have that almost, we have almost we are testing from battery cell, module, and pack as well, and our maximum pack testing capability is up to 250 kilowatts max, and up to 450 volt battery pack we can test. So as I've already that introduced, we are working with the different national institutions for the battery related standardization, research proposal, R&D missions, and then the policy as well regarding energy storage and battery for different EV and solar applications. So yeah, so before going to that, so this is just this slide introduce about the different type of UAV, that what type of UAVs are being used currently, and then what are their future demand. So and their future applications. So mainly in 3 different areas: civil, defense, and environment. So I have just put this table here as an introductory slides. They are different type and then different size. So then battery selection is important for that all type, because battery will define their flight time and their safety as well, and then as a power plant for other application in the drone. So major factors batteries is playing in the controlling the drone flight time and then output. So basically currently the 2 different type of batteries are being preferred for the UAV application. One is nickel metal hydride, and now I think most prominent is the lithium batteries. And again, in the lithium battery, we have the different options, we have the different chemistry and a different format as well. So we have to select, and we have to have the pros and cons, and then we have to have the trade-offs, that safety, price, life cycle, energy density, power densities of the battery. So these are the parameter for the selection of the batteries used in UAV. So it is similar kind of things, like for example, the battery you are using for the solar application cannot be used for the EV, and then the similar battery cannot use for again in the UAV application. So the choosing a proper lithium-ion batteries is very much important for the safety as well as the performance of the batteries. So what we require next thing is that we have to have one algorithms for the critical importance to ensure the safe operation of the battery for the life cycle, so that we can predict the life cycle of the batteries after how many flying hours we have to retire our battery. So that is very much important, because when the battery is going to its end of its life, so before that it has to be retired, otherwise we might face some accident. So the larger the capacity of the battery, the longer the flight time, and the larger the power density of the batteries, that fast we can charge over the batteries. So the energy density, power density, and life cycles are important parameters. So few terminology are there, so might be most of the people might be knowing. Yeah, so state of charge. So state of charge is like, for example, your battery is fully charged, so it is called 100% charge, or it is called 100% SOC. So if you take like 10%, so then it become like 90% SOC. So similarly, the depth of the discharge. So depth of the discharge is when you discharge complete your batteries is called 100% DOD, but most of the case we don't discharge completely. For specification, we make it up to for the like 80% DOD. So again the battery pack. So battery pack is nothing but the different cells are combined in series and parallel combination, including battery management system as well as a thermal management system. So C rate, the C rate is the current, the rate of the current at which we are discharging our battery. So for example, we have the 100 Ah batteries. So 100 Ah battery, if we say that 1 C, we have to discharge it. So we are discharging the battery current. The battery will be discharging with the current of 100 amps. Okay, so these are the, yeah, so as I have mentioned that most preferable battery system used for the UAV are the lithium-ion batteries. So in these slides, you can see the different formats. And then in next slide, I will show the different chemistry. So in individual chemistry can have the different formats as well, so as per the requirement of the customer. So if you see the left or bottom pictures, so what is the inside of batteries? So it is mostly that current collectors is there, one side anode is there, other side is cathode is there, and then polymer electrolyte or polymer separator is there. So which avoid a short circuit between the cathode and the anode. So that which are the cathodes and anodes are the materials which store the lithium ion. So more you store the lithiums, more is the energy. More faster you store the lithium, so more higher is the power density, or that and then more faster you can charge your battery. So how this charging and discharging and depend on the shuttling of the lithium from one side to another sides through these electrolytes. So this is a basic chemistry for the lithium-ion batteries with the different formats. So these are the different formats. So then you have in this slide, you have the different option, which chemistry you want to select. So you will find that you will see you can see in this graph that voltage versus capacity graph. So you have the different voltage range and different cutoff conditions also. So you have to find what is the suitable voltage for my drone. So you will select a particular cell chemistry which are more safer, and then which has a higher energy density and which can be faster more. So for example, here if you see if you have the LTO based chemistry, so that is one of the highest power chemistry available right now. And if you see the table, so I have just summarized the different energy densities at the material level as well as the cell level. So that energy density we can select from this table, and then accordingly we can choose the particular cell. So once you have selected your cell, then you have to make your battery pack. So because you cannot use the cells, you have to have the big battery packs with the safety features. So safety feature will be mostly covered by your battery management system attached with which is the electronic circuit. So the battery management system, the role of the battery management system is the monitoring and the measuring, calculating and communication and controlling the balancing. So all these are important things for the safety of the batteries, because what the clause has been included for the compliance of the batteries, two main clause. One is the safety and another one is the performance. So that safety compliance will be covered by these two things. One is the battery management system, and another one is the thermal management system. So that it will also, because sometimes what happened, there are different of cells combined in series and parallel combination. So some cells are 100% charge and some will be like some difference will be there, 99% or 99.5%. So that point, if it is remain for longer time, so your battery pack performance will deteriorate with the time. So that's where we need the self balancing time to time. So that self balancing will be again done by the your battery management system, because it is also controlling individual cell, and it is also monitoring individual cell temperature, individual cell voltage, and the discharge performance. So this is a battery pack. So battery pack is just combination of your battery cells, and then including with your battery management system and thermal management system. So this is the basic architecture. In this slide I have shown for the that how to make a battery pack. Then once you have the battery pack is ready, available, so the main important thing is that you must know that what is the safe operating zone for the temperature and the voltages. You recently you might heard about that accident of the different batteries in the EV application. So same issue might come with the UAV as well. So there are we have to have that different zone, like safe operating zone of the batteries or battery pack, then limited operating zone. Okay, we can run or we can use the battery in this particular zone, but not for longer time. Then it comes the danger zone or no operation zone. So how these zone will be defined? It again depend on the chemistry. If you see the right side of the figure, so we must know that where the deterioration is coming. So I have just put some temperature. So what is the suitable working temperatures for the electrode and the separator, at what temperature what reaction happen, and how the battery will caught the fire. So these are the safe operating zones defined. Everybody that who is manufacturing or who is making that battery pack, so he must be knowing these operating zones. So accordingly he will design his battery management system, and the battery management system must be different for the different chemistry, because the different chemistry have different charge and discharge rate, different cutoff conditions, and the different voltage ranges. So the battery management system should be defined differently for the different. You cannot use a common battery management system for the different chemistry. So this is the safety zone. So you have now you have cell selected. You make the battery pack. Now you know your limit of the operation of the how we will use this battery pack in UAV or whatever application, EV other application. So once you have all these things, so then you can fix your battery pack as a power source for UAV or the EV and for any other application. So then next comes to the certification. So once you have that everything is ready, the battery pack is ready, you have to certify it from the any enable accredited laboratories. And currently, for example, I have summarized some safety standards which are being used in Europe and different other countries for the safety uh, of the batteries for the drone application. So for example, UN 38.3, which is used for the high altitude simulation, IC 62133. So IC 62133, the same standard which Bureau of Indian Standard has adopted for the as a different name 16046. So which is mandatory for the lithium-ion batteries, mandatory for the importing the lithium-ion batteries, and similarly that same standard has been used for the drone compliances for the safety. So that IC 62133 is equivalent to IS 16046. Then EU battery directives are there. Then for commercial battery, that UL 2045 standard is available. And for portable, I think it's yes, the same repeating of 62133. And safety in the transfer of lithium batteries, the 62281. So these are the standards for the transporting altitude simulation and the safety test being used worldwide for the EV application as well as for the drone application. So that now I will come to the compliances for the batteries. So just in these next 3 to 4 slides, I will just show that what are the compliances and what performance testing we can carry, and I will show some data also which we are testing the batteries performance data, which for the drone application as well for other application, how the data is being collected and what type of data we require for the batteries. So that clause 3.2 is for PowerPoint batteries. So in this also the two type of clauses. First one is the safety, and safety is, as I mentioned, is covered by 16046. What are the tests there? So there are different 8 different tests. So one is continuous charge, then molded case stress, external short circuit is there, free fall is there, thermal abuse, crush, forced discharge, and transport. So this test has been described in detail in this particular slide. So all the tests we have to carry it out for the safety. Must have the battery must have in 100% SOC. So it means battery should be in fully charged. So 100% SOC means battery must have in full charge condition. So then we have to perform all these tests as I have mentioned or described in this slide. So for example, continuous charge. So continuous charge, how we have to follow the test procedure. For example, you have a given battery to test lab. So we have to charge it fully and then again overcharge it for 7 different days. So the what we have to observe and what is the acceptance criteria for this? There must not be the fire or any explosion or the leakage from the batteries after overcharging for the 7 days. So similarly, that case stresses, fully charged batteries are exposed to that high temperature of 70 degree plus minus 2, and then batteries again, no physical distortion or any internal protective component should not burn or no fire or so no explosion. So similarly that it should not have fire and explosion. So external short circuit, we have to sort the batteries by using that 80 milliohms resistors, and in this case also we have to keep the battery for 24 hours in this condition. So fully you have to charge the battery fully, and then you have to connect your positive and negative terminal by this resistors of 80 milliohm, and kept it for the 24 hours at ambient conditions. So it should not have any fire or explosion or bulging of the batteries. So sometimes it might bulge, but it should not explode actually. Then free fall, so you have to just it's a simple test. You have to drop the batteries from 1 meter height in the different by keeping the battery in the different phases, like the horizontal and then flat way and a different way on the floor. The floor must be it should be the concrete floor, not wooden or others. It should be the concrete floor. So again, after falling from 1 meter height, battery must not explode or the fire should not be there. So next one is the thermal abuse test. So in thermal abuse test, the fully charged battery, we have to again charge the battery up to 100% SOC, and then at the room temperature, or that we can say ambient, which is 25 plus minus 5 degree for it is taken from IC, but basically in Indian standard mostly we have the ambient like 27 plus minus 3. So the oven temperature to raise 5 degree per minute to up to 130 degree. So the battery has to be there for 30 minutes at this particular temperature, and then the acceptance criteria is similar, same as for this. So similarly, other tests are there. So all are mentioned here. So battery should not fire or must not explode after during carrying out these tests, because the safety is very much important for any application, even for electric vehicle or the drone or any other applications, because there is a lot of the damage can happen due to the fire or due to the accident of the batteries explosion. So these are the safety tests. This report must be provided by the customers who are using these batteries in the drone. So second comes now for the performance test. So in performance test, there are two stages. We have to verify this test report from an enabled accredited test laboratories. So in the performance test, mostly what test we have to carry out. So the energy and the power capability. So energy means we have to measure the capacity of the batteries at the different C rates, and the C rate will be either defined by the customer, or if someone want to follow the standard, they can follow similarly that 16047 or any other standard for the performance testing as per requirement of the drone actually. So these are the just setup. I have shown here how you connect the battery. It is you kept this battery in the oven, and then it is battery cycler or battery tester is controlled by this host computer. We make a program, so we can make the program for the short term and the long term. So once you start the program, so life cycle test will run for many days to the months also. So that this way you have to perform the life cycle different tests like capacity or the power capabilities. So power capability is nothing but that it is high rate discharge test. So you have to demonstrate that how fast you can discharge your batteries, and it's not only, it is as per requirement of drone. So while we are lifting the drone from the ground to the some height, so that time we may require very high current. So that this test is important for the lifting of the drone from ground to some height, and then maybe in cruising condition we don't need that high current. So we have to have that power profile in such a way that and that profile, that power profile might be and must be given by the drone manufacturer, because he will be knowing that how it is flight condition is, how much current, and according to the weight of drone, how much current he need to lift the drone from the from bottom to some height. So this is the high power capability test. So we need very high discharge current that time, and maybe for few seconds only. So this type of testing are known as the power capability of the batteries. So I have already defined this high rate discharge, and then come to the life cycle test. So life cycle test, again, that it is important that life cycle test, we can charge battery, and we need the fast charging, and then we have to discharge according to the power profile of the drone. It is not just simple that one single C rate you have to discharge. You can have the multiple C rates. So like pulse charging, then slow charging. So that way we can discharge our batteries, and then we can do the life cycle testing. So there is an option that in life cycle test, it's again depend on the manufacturer how many cycles he wants, or he can tell, okay, I want up to till 80% depth of the discharge. It means you keep cycling, means you keep charging and discharging the batteries till your capacity come to 80%. So it means if you have the 100 Ah battery, so you have to keep charging and discharging till you get the discharge value of 80 Ah for 100 Ah battery, so that 80% DOD, or either you can give the number of cycles. Okay, I want this number of the cycles, charge discharge cycles, so which are enough for my total life of the flying life of the drone. So that air life, or how much time it is spending in the air. So accordingly we can tell that these many of cycle, or either of the total 80% depth of the discharge. So these are the cycle left. So once these reports are ready, you can submit it to QCI or that relevant for that forum. So these were the clauses actually. So first was the safety, and the second was the performance clause. Performance clause are two type of tests. One is short term, as I mentioned. So short terms life cycle power capabilities, and then long term is the life cycle test. So these two tests belongs to the performance testing of the battery. So here I have shown a few examples how the data looks like. So here if you see the bottom charge discharge profile, or the voltage capacity profile, which test where the tests are carried out for the high power battery. So from C by 3 to 3C, we have to charge and discharge these batteries at not only at the room temperature, but at -10 and +40 degree as well. So you can see performance, and accordingly we can calculate the capacity as different temperature, because the capacity will vary temperature to temperature. So it is very much important. We must know that, for example, if 25 degree, this is my capacity, but if sometime your drone is flying at 40 degree at different areas, so that time we must know also that how much capacity it will deliver at 40 degree. So these are tests are important. So we have to do the capacity test, or that energy performance energy performance test at different temperatures. So that as I have mentioned that it's not important only to do that constant C or constant discharge rate of the batteries, because there is a lot of fluctuation in flying due to the, for example, air drag is there in opposite direction. So that time we might require more or less current. So it is not drone is even in cruise conditioning, so it is not taking constant current. So in that way, what we can do, we can have the different type of power profile. So sometimes it is pulse current, then again it is giving slow current. So in this data, whatever I have demonstrated here, so this is data for some batteries, or for the drone application we have just doing in our laboratory. So this data is from our lab. So in single time you can have a lot of parameters. you can have the data for a lot of parameters like voltage, current, power density, capacity, as well as temperature monitoring, and then different temperature, how the discharge profile is coming and how the discharge capacity is changing at -10 and then +40 or +45, or at higher temperature or the lower temperature. So these tests are very much important for the safety as well as the performance of the UAV. Okay. And this is the I have already explained the life cycle test. So this is the data. Looks like as I told, we have to do up to 80% DODs. For example, this batteries we have tested up to 2,000, more than 2,000 charge discharge cycles, and not a very not only at a slower C rate. It was done like 2C charging and then 3C discharging. So 2C charging means charging current was almost 100 amps and then discharging current was 150 amps. So we have repeated it to more than 2,500 cycles. So still the capacity was above 80% of the for this particular batteries. So these are the important tests for life cycles as well as for the short-term battery use in the any other UAV or any other application. So this there was one issue actually that because that whatever the safety testing we are carrying out, that is applicable for the portable application. So portable application, for example, in future we have the bigger size of drone. So this is just suggestion that we can follow this particular standard, because in electric vehicle they are using this particular standard for large battery pack or system, which is ISO 12405. For part 4 is for the performance and part 3 is for the safety of the battery pack. So this is the actually much better suited standard, because it tells that we have to do testing of the battery pack which has both BMS and thermal management system. So it is the system level testing. So ISO this particular standard is covering both performance and the safety test for the bigger size of battery pack, which might be useful for the bigger size of UAV in the future. So some of the tests I have just summarized here for the safety: mechanical test, vibration, mechanical, or this climate, or the water immersion, exposure to the fire. So these tests involve already included in this ISO 12405 part 3. So similarly for the performance, there are different dynamic discharge profiles. All these types of energy efficiency, life cycle, and endurance tests are covered by the part 3 in the performance. So these are the for the suggestion for the future, for the if someone would like to have that very big battery pack used for the drone application. So thank you very much. So these are I was a bit faster. So if any questions are there, so I think at the end of the session we'll have that chance. So this was that's from my side. Thank you very much.
Thank you, Dr. Rana. Do we have Razak sir joined in already? Dr. Razak, Mr. Razak.
Hello.
Yes. Sir, if you wanted to make a couple of points that were left out in your presentation, then I want to welcome you.
Which one?
Razak sir, last time when you got disconnected, were there any points that were yet to be discussed?
No, I think that's it.
Okay.
Some hints what I showed in my last slide, that's the one.
All right. Then we'll move to the next presentation. The next presentation is by Mr. Udit Kaul. I hope you have joined in. Yes, just allow me one moment.
Yes, I'm there.
Yeah.
Hi. Hello, Mr.
Just
Udit. Am I audible?
Yes, I'll just make the introductions. We have
Sure.
Mr. Udit Kaul, who is currently working as the Deputy Manager in the Electrical and Electronics Lab at the International Center for Automotive Technology, which is ICAT. ICAT is a testing, homologation, and R&D Center for Automobile Setup located in Manesar under the Ministry of Heavy Industries, Government of India. Mr. Udit has extensively worked in the field of testing, validation, and development of CNG, LPG component, speed limitation devices, hydrogen fuel equipment, and other components during his career with ICAT. He has also been instrumental in setting up the CNG LPG lab and a state-of-the-art battery testing facility at ICAT. He represents ICAT at many technical panels under BIS, AIS, and on regulation formulation for EV and XEV and their components. He is actively involved in the new facility development for EV validation and has keen interest in new technology topics related to electric mobility. Mr. Udit will be speaking on the testing requirements for battery from ICAT's perspective. Mr. Udit, please go ahead.
Uh, Hello, everyone. Good afternoon to all. First of all, would like to thank UCI for organizing such an event, and then for Mr. Smith Shah for a very good introduction. So I'll just start off my presentation. Probably this is divided into three parts. First, there would be the introduction of ICAT, International Center for Automotive Technology, and then uh, what all certification and validation tests that we are currently doing for automotives, and then what we are doing for drones, why we have chosen those tests out of the automotive sector, and then a good elaboration on what these tests are. So yes, so this happens to be ICAT. ICAT is International Center for Automotive Technology, situated in Manesar. This is a center under NATRIP, National Automotive Testing and R&D and R&D Infrastructure Project. So ICAT basically provides services for testing, validation, design, and homologation. So we were established in 2006. We have a human resource of about 592 plus people. So the location is at Manesar, which is about 38 kilometers from Delhi Airport. We have basically two centers in Manesar itself. Center 1 is about 8 acres and Center 2 is about 46.6 acres. So this organization is basically a leaf of branch, or I should say a branch of Ministry of Heavy Industries and Public Enterprises, having a total investment of about 3,742 crores, out of which in ICAT there is about 1,350 crore investment from Government of India. So this is the ICAT authorization and accreditation. So basically ICAT is authorized for type approval and COP of automobiles under rule number 126 of CMVR, which is governed by MORTH. We are also authorized by CPCB for emission and noise type approval and COP of generator sets. We are accredited by NABL for various domains. Battery and environmental testing is one of such domains. We are also accredited by VCA, which is a UK government agency since 2008. We are CAFE Secretariat by MOTH. We are BIS recognized for testing of pneumatic tires, safety glasses, engines, and lamps, LED lamps, and UPS systems. The entire facility, which is about both the centers are ISO 9001, 14,001, and 45,001 IMS accredited. The facility is also recognized by CIRO. There are a different there are different certification partners across the globe that we deal with for certifying automotive and its components from India across the globe. So Kiapi Korea is one such. Kiapi Korea is there. Then IDIADA Spain is there. NRCS South Africa. TUV Red in Germany. TUV Sud and Nord both for Europe are there. There are certain MOUs also which we have signed for different activities such as educational, business development, product development. So would like to tell you about that. We have one with Kiapi Korea for certification work, Katak China for joint certification as well as development work, Millbrook UK again for joint development and certification, Brunel University for electric powertrain, Argonne University for Powertrain, Ohio for University for Noise, Vibration, and Harshness, Hangzhou already for business development in China. Okay, so then this gets me to basically the major areas of battery testing and validation. So I would probably divide that into four segments. First, performance, certification, life testing, and then safety. So the performance testing can be further on divided into electrical performance, environmental performance, mechanical or physical performance, and then there are some application specific performance tests which are also there. So this would be the electrical performance tests that we usually do at ICAT. The basic test of these batteries are basically a capacity test as to determine the charging and the discharging capacity of the battery. That is how much current it can basically have and the load it can basically take. So capacity is generally determined in AH as very well explained by Dr. Kuldeep. There are a few other tests, charge efficiency tests, discharge efficiency tests. So basically in all these tests we see uh, what is the efficiency if, say, suppose certain number of cycles of batteries have passed, and what is the efficiency of batteries at different cycles. Say, suppose what is the efficiency at 100 cycles or 200 cycles or 300 cycles. So then there is retention of charge, power density, regenerative power density. So all these tests, pulse power characterization. So all these tests are basically to determine various technical aspects like power, charge, AH, the maximum current that it can hold, maximum current that it can give. So all these tests are done because of this, just to check the electrical performance of the battery. So this is how a basic setup for a battery test looks like. We have a battery test system from different manufacturers. We have a laptop, as you can see, a PC, as you can see, wherein the software for this system is running, and then there is an environmental chamber. So all these combined basically uh, actually help us for the testing of life cycle along with different chambers. So temperature chamber basically maintains the chamber. So suppose from minus 60 to about 200, so we can vary it. We can also vary the humidity that is inside the chamber so that damp heat test can be done. So damp heat has different temperature ranges as well as the humidity can also be varied along with the battery running under charge and discharge. So the battery is undergoing charge and discharge along with the variation in temperature and humidity. So this is what a damp heat test is. Then there is thermal shock. Thermal shock basically is done onto the battery pack. Say suppose the procedure is like this, that the battery is kept say about 10 hours under minus say suppose 40 degrees Celsius under extreme conditions, and then within a span of 4 to 5 seconds the temperature is changed to about 60 degrees Celsius or 40 degrees Celsius, just to see what happens to the battery when there is a thermal shock or a sudden change of temperature. So we study the effect of that. Then there is salt spray, water spray, and dust spray. These are basically water spray and dust spray are basically characterized as ingress protections. So this basically study the effect of ingress of water and dust to different levels. So we have IPXX. I mean, XX is still 9K. So different levels of ingress protections are there. And then salt spray, we study the effect of corrosion, which is there. I mean, there into the atmosphere. So 5% NaCl solution, fumes of the solution is enthralled upon the battery pack, and then the effect of this salt spray is measured. This is a setup on the left, you can see a setup of the vibration test, and the right, you can see a chamber which is about 2.5 meters cross 2.5 meters cross 2.5 meters. So basically, the drones that are used are basically tested on these vibration checker and the the chamber. This can also be used in a combined form, as in we can see the effect of the vibrations along with the changing humidity as well as the temperature. So these two are very critical tests. And then there is shock test. We study the effect of a sudden jerk or a shock onto the product. So say suppose generally a value of about 30 G, which accounts to be 300 meter per second square, is put onto the product, a shock, and then the study of the capacity, a standard cycle of a capacity is being done to study the effect of those particular shocks onto the battery. Then there are almost similar kind of say as like bulge and packaging test, more of a packet, uh, more determined to study the quality of the enclosure of the battery pack. Drop test, rollover, clamp tightening tests are basically for mounting. Okay. So drop test, rollover test, and clamp tightening tests are basically to study the effect of of the adverse conditions onto the mounting of the battery pack, the case of the battery pack. Um, Mechanical performance tests. So as I already explained, this is a fair bit of example of on the right, you can see on the left, you can see the battery is being mounted on the vibration checker, and on the right, there is a load cell connected to the resistive load connected to the battery to discharge this battery, so that you can actually see what is the effect of actual vibration or shock onto the capacity when it is discharged or charged. So this is one application specific performance that we did for this was basically a R&D project. In this, this was a battery of a semi-hybrid retrofit MUV, which had to go high rates of charge and discharge for a very short duration. So there were a lot of transient given to high pulses given to the battery to study the effect in case there is thermal runaway or there is any negative effect of life. So this experiment was conducted to perform temperature profile characterization on these LFP batteries. Uh, these these uh, these cycles were actually derived from an actual road load data accumulation or from the acceleration and the deceleration pattern of SUV during a combined city run. So from the actual data that a battery experiences on a vehicle, we created a charge and discharge cycle. Uh, so that is what we represented in this project. These are basically the safety. Now comes the safety part of the battery testing at ICAT. So first is the penetration, then short circuit, overcharge test, over temperature, high altitude fire resistance. So I'll be explaining these in detail. Uh, on the left, you can see short circuit test. In this, the positive and the negative terminal of the battery is basically connected through a hard short. So whenever such kind of a situation happens, there is approximately 100 times the current which should actually flows through the entire battery, and the chances of thermal runaway increases. So we study the effect of such conditions. We emulate such conditions over here and study how the battery would respond. And on the right, it is basically penetration. We basically penetrate the cells through and throughout to actually see if there is any fire or explosion. So all these safety parameters is basically to cater the thermal runaway of the cells as well as the battery. Um, so on the left there is the chamber. It represents an altitude chamber. This chamber basically uh, what it does is simulates the effect of higher altitudes onto the battery. So higher altitudes will 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 have low pressure and low temperature. So that is what it did. That is exactly what is simulated in this, and we study the effect along with the charging and discharging of the battery. So we can study what will happen if your drone or basically the drone goes into a condition where there is less of pressure and the temperature is also less. So we can actually study that effect. The On the right, it is fire resistance test. We basically study the effect of fire if at all enthralled upon the battery. So basically, the battery should not explode. That is how the acceptance criteria is. So this is basically a small example of the fire test that we have done on a RESS, which contained flammable electrolytes. So this is example of a crush test, which happens in IS 16046. The purpose of this test is to actually verify the safety in case there is a crash situation of vehicle, or say suppose, or drone in this case, in this scenario. This was a leakage test that we did for OEM, for a bus manufacturer, and we studied the effect if there is any leakage in the entire battery pack. So this battery pack was approximately 600 volt battery, 640 to be precise. And we studied the leakage if there is any inside the uh, battery pack. So this is the IP test rig that we were talking about, the water spray test. So we basically study the effect of ingress of water in various packs, so that the water should not enter from the joints of the enclosure. This is the drop test. We study the effect of the battery being dropped from a certain height, unintended drop from a certain height, to check if there is any damage or electrolyte overflow or fire or explosion which could occur because of that impact. So now this brings me to the more interesting topic of life cycle testing. So we have different, so that this slides gives the capability at ICAT what we have as of now, what all equipments we have as of now to test your batteries. So we have more than 50 channels available, ranging from 600 watt to 80 kilowatt. Voltage range of about 1.5 volts, that is from smaller cells, to about 1000 volts we have, and the current ranges up to 1200 amperes uh, is available. So power range of about 720 kilowatt. So I think the range that we have is the most as of what we know at ICAT. So it's the state of art facility that we have. So we have installed systems from Mrs. Byte and Mrs. Chroma. We have data logging analysis capabilities, temperature control chambers and water baths are possible, and multiple channels. So we can put multiple channels of these 600 watt to increase the current rating, and then to achieve C1 rating, or I mean whatever rating that the battery manufacturer can claim. So this is accelerated life cycle testing. This was done on a VRLA battery, which can also be done in a lithium ion, wherein a chamber can be kept. So I'm just explaining an example of what we did, which can also be done on a drone battery. So this was done just to check the severity of these high-level test methods wherein high charging, discharging, and high temperature are done. So this was like the AOD was achieved in about 960 cycles. So this can also be done for the batteries of drone. Uh, this was basically a validation by Coulomb counting. So Coulomb counting is the basic general method of validating a life cycle, as Coulomb being the smallest part of current, the basic building part of current. So in this we had basically done this for a done this project for a robotics lithium-ion battery, which is almost similar to that of drones, where we calculate the SOC by measuring the battery current and integrating it with respect to time. So thus the charge and discharge cycles were used for Coulomb counting. Yeah. So this basically is a hardware in loop system that we have got from National Instruments USA. This basically helps us validating and testing the battery management system as well as the power control, power electronics of the battery. So in this, there is a single issue which can be functional, which can be used for functional and endurance testing, either in open loop or closed loop feedback system. So multiple issues can also be tested because we have about 28 channels of different test setups that can be made. And this is very much instrumental in testing for battery management system. So we can emulate all, we can basically simulate and emulate all the I mean the faults that are there in which happens on the field. We can provide that to the PMS and actually study the responses of the PMS which happens on field. This is basically an EMC test facility which we have at ICAT for smaller components as well as for batteries. The component test chamber, we call it a component test chamber. We have a vehicle or a drone test chamber which is different to this. So this component test chamber is about 8 meters, and I mean major Indian and international testing for as per OEM standards we can do over here. Chambers which are suitable for RMS field strength of 200 volts per minute, frequency ranging up to 10 kilohertz to 40 gigahertz. The chamber can also used on board radiated emission under CESPA 25. Dimensions are written there 8.5, 7, and 6. So there is a shielded control room exclusive for CSAC with advanced instrumentation. And there are a wide range of offboard and onboard radiated immunity and radiated and immunity antennas which are there for testing. So in this EMC, just would like to tell that in this drone testing, only immunity testing is being done. So we study the effect of various frequencies in the atmosphere onto the drones, and we study that there is any malfunction happening because of that electromagnetic waves which are present. So that is what we study in cases of drones. So this happens to be the 720 kilowatt battery emulator. These are two channels, each of 360 kilowatt, and this can also be used as source or sink, that is load during regenerative application of the battery. Maximum current output is already mentioned 1200 ampere. Voltage about 1000 volts DC, but not exceeding 720 kilowatts. So there is a power limitation to this product, which is, I mean, it's huge. 720 is really huge. Climatic test facility, we have different explosion proof chambers which are installed for battery testing. Chamber 1, 2, 3, we have biggest size would be to 2500 mm, cross 2500 as already explained. So these are all UCAR, both two of them are UCAR level 7. So there are like, so there is a nitrogen application. If we we continuously study the effect of rise of temperature in the chamber, and in case there is a rise of temperature in the chamber or onto the product, the nitrogen in the chamber automatically activates and then surpasses, and thus reducing the oxygen and thus suppressing the fire. So the chances of fire in the lab are pretty less. This is the by this is basically the capability that we have. By throat cycler, we have about 24 channels, about 80 volts, 100 amps. By throat 16 channels, 18 volts, 25 amps, and then there is one about 1000 volts to 600 amps. So the basic test that we have finalized for drones is this. The table is very much visible. I mean, we do about 6 tests versus overcharge, vibration shock, short circuit, capacity test as per ISO 12405, and then life cycle test, which actually the number of days and the time is actually dependent on the input from the manufacturer, and then only we can decide the number of days or hours for this test. Basically, we require about 5 set of batteries, or battery module or battery pack, which is approximately done in 7 to 8 days. But life cycle depends on the time limit for life cycle depends on the customer. So this happens to be the vibration test. The pictures are the same. So this is how the drone is tested. It should be carried out on room temperature, not exceeding 30 degrees Celsius. It happens on all the 3 axes. So X, Y, Z, all the 3 axes, the battery has to be tested for each of 2 hours. The battery onto the battery, the vibration test. In the vibration test, there is an acceleration of 3G, which is put on all 3 axes under a frequency bandwidth of 30 to 150 hertz. So we study we actually study the effect of vibration after after the vibration test. We do a standard cycle, standard charge discharge cycle, and there has to be the capacity has to be within 90% of the actual initial capacity. So overcharge, basically the battery has to be under 100% SOC, and then with 0.1 times the C10 capacity of the battery it is charged. The requirement of batteries is that there should be no melting of components, fire or explosion, or any other physical damage to the casing or mechanical parts. Mechanical shock, as I've already explained, so this happens to be the picture you see happens to have a shock test in y-axis. So this is how it is done, and it is almost the same as that of vibration test, except vibration is a continuous procedure of about 3G. In this, we give an impact of about 30G and 15 millisecond duration. So 10 shock each on each axis have to be done. Yes. So this is short circuit test. In this, we study the effect of in case there is an internal short or an external short. We emulate that, and we basically connect the positive and the negative terminal and see if there is any fire or explosion. Test is to be carried out in a room temperature not exceeding 30 degrees Celsius. The entire circuit sh the entire circuit should have the internal resistance less than 5 milliohms. Only then the testing has to be started, and there is a hard shot applied when we connect the positive and negative terminal, and then we have to keep it for 10 minutes like it. Then there is a capacity test as per ISO 12405, which was explained by Dr. Kuldeep also. So we do a charge and discharge as per of the battery as per C3 rate, and 5 number of charging and discharging are performed, and it would generally take about 30 hours, something like that to complete. This this is the final life cycle test, the last test which is left. So in this we do charging, a number of cycles of charging and discharging are defined till the battery reaches up to 80% DOT as specified in the notification. So for example, the customer has declared that the battery pack having a capacity of 16 Ah will reach up to 80% in 250 after performing 250 cycles. So what we do is we take so at C1 rating. So C1 rating means that 16 Ah 2 hours to complete each cycle. So there are 250 cycles. So somewhere about 500 hours or equivalent, which are equivalent to about 21 days. So it takes that much time. It is also possible to increase the current charging and discharging rate, but then the severity of the test will increase and the chances of failure would also increase. So this is something that should be kept into mind before asking for this test, because the whatever the manufacturer will provide, according to that data we are going to test. So this has to be very thought of very nicely as to what the capacity should be taken in this life cycle test. If you increase, if you want to decrease the number of days by increasing the amperage of the charging and discharging, it should be very carefully thought of whether the battery can take it or not. I mean, the manufacturer should consult the battery manufacturers, and then probably this decision should be taken. Yeah. So, thank you. Thanks a lot. I would give it to Mr. Smith now for further deliberation. Yeah.
Thank you so much, Udit. I would want to take this opportunity to thank all three of our speakers. It is really wonderful to keep listening to our speakers and get in-depth clarity. Uh, Now, in case uh, CS, if we have time, we can take a few questions.
Yes, we can take few questions. And Marshall, I can see that there are some queries. For example, do ICAT also provide BIS certificate? So ICAT is not supposed to provide BIS certificate. BIS certificate or R registration number is being provided by BIS only. And what is DOD? Please explain. So if Dr. Kuldeep Rana is there, he can answer this query. What is DOD?
Yeah,
Dr.
I'm
Rana,
here. So yeah,
are you
yeah.
there?
So
Please.
yeah,
Yeah.
yeah. So DOD is that's defined as the depth of the discharge. So depth of the discharge, for example, if I say I have 100 Ah of batteries, and if I want to life cycle on these batteries, so customer will say up to 80% DOD you have to test. So for example, 80% DOD means 100 Ah batteries. If after, for example, 300, 400 cycle, if it is 100 Ah batteries give 80 Ah, so that is the that much of the DOD actually. So up to 80% DOD. So whatever the loss in that capacity after that from initial, so that is for the depth of the discharge up to 80%.
Jana sir,
Hmm.
please explain the other queries as well.
What is the other query?
Sir, which I have shared with you.
Yeah, so BMS is not required for the discharge time, right? That query?
Yes, sir.
Yeah. So BMS is required actually. So it is not only for, it does not means it will stop the current while drone is in flight condition, because drone will fell down. But BMS is required for other purpose. For example, to monitor the temperature as well as current during the discharge. What if the current is behaving different way? So that BMS will monitor that current so that we can land our drone within, for example, I want, okay, I have seen some abnormality in the current. So then I have to land our drone within, for example, 1 minute or 2 minutes. So that's why BMS is required. The second thing is that for the temperature. So due to, if it is sometime very high, due to some high current, so temperature go beyond your range. So who will monitor that temperature? So the temperature will be again monitored by the BMS, so that you can again bring back your drone. And then not only for this emergency landing, but also for the future health of the battery, state of the health of the battery, so that if some cell is, for example, you have 50 cells, so one of the cell is not behaving properly, so BMS will tell that things that because of this particular cell is not performing well. So BMS is not only for the cutting down the current, but it will monitor also the parameters which you can use for the diagnosis of the battery for future application, for future use, for further use actually. So the second question was again in that only, what is the thermal abuse? So yeah, so as I mentioned that due to the, if temperature rise due to the some region, even in one of my slide I have shown that which temperature or what temperature we have to be careful. So they are different temperatures. So temperature might be increasing due to very high currents, and what if it is go beyond your set limit? So in that case also, what will happen that there are some temperature range for the separator battery or polymer electrolyte. So polymer electrolyte will start melting. Okay, so that temperature, if it goes increasing and increasing, so then some chain reaction will start. So your cell might be explode. So that's why again this region again we need the BMS advice. I have defined what is the it will lead to thermal abuse. So that is the thermal abuse due to a very high temperature. Cell chain reaction will start inside the cell, and it will fire will occur, and then battery will explode. So this is called the thermal abuse actually. Yeah. Hello. Yeah, that's from my side.
Okay. Here is a question. What is the life cycle of raw material of drone? So life cycle of a raw material of the drone will depend on the material you choose. All material like different aluminum alloys will have a different life. And similarly, you have to check from the manufacturer. And similarly, you can check the life cycle of the raw material. Coming to the, is TPM based hardware flight controller a mandatory compliance for the certification? Yes. TPM based hardware is a mandatory compliance for the certification. I hope, sir, there are no further queries and we can move forward.
Thank you, Marshall. As we come to the close of our second session, and I would like to thank the moderator, Mr. Shah, and the speakers, Mr. S.A. Razak, Dr. Kuldeep Singh Rana, and Mr. Udit Kaul for their insights. Moving further to our third session, documentation from the manufacturers to demonstrate compliance and manufacturer's perspective. Let me welcome once again Mr. C.S. Sharma as the moderator of this session, as well as the next session. Mr. Sharma, over to you, sir.
Thank you, Pooja. So this session is based on the requirements pertaining to documentation and other test requirements, which are mandatory in nature to demonstrate the scheme compliance. So what we understand that what are our learnings throughout this certification process, we have to see that how those learnings can be percolated down the level in terms of further compliances which need to be ensured by future applicants. So in this session, I have with me Mr. Tulsi Raman, and Tulsi Raman represents DGCA. He is working as a deputy director in aircraft engineering department. He is having more than 16 years of experience in the field of civil aviation. Basically, he is responsible for type certification and validation of type certificate of large aeroplanes and international cooperation related activities. Since October 2020, he is responsible for unmanned aircraft systems, for example, US and drones, certification and operations in India. So I would request Mr. Tulsiraman to share their experiences, their, I would say, actions which they are supposed to take in terms of new initiatives in near future. So please enlighten on those initiatives and what are your learnings and experience throughout this type certification journey, in which we have seen two type certificate which have been recently released. So we would like to listen from you, Mr. Tulsiram. Mr. Tulsiram, are you there? Okay, I suppose he is not able to share option or mic. So I would request if our team can help
Sir,
him.
Ashish is enabling him to
Okay,
join.
fine, fine.
Sir, now he can unmute himself.
Thank you. Just all. Am I audible? Can someone confirm that?
Yes, you are audible. Yes. We can see your screen as well.
Sorry, the call dropped.
No issues, no issues. You can continue, please.
Can you see my screen?
Yes, we can see that.
Okay. Today I will speak briefly on the civil aviation concept on the whole, and type certification with respect to manned aviation, type certification with respect to unmanned aviation, and the expected targets in the way forward. Dgca is a civil aviation safety regulator of India. For Dgca, the primary civil aviation safety objectives are safety of people on ground, safety of people on board the aircraft, and safety of the associated property. How do we ensure safety? By the airworthiness certification of the machine, registration and marking of each aircraft for the purpose of identification and tracking, by assessing the competency of the personnel involved like pilot, AME, etc., by assessing how much risk is involved in the intended operation and certify the operation, by assessing the competency of the organization, whether they can perform intended tasks and approve them if they are found competent. For example, design organization approval, production organization approval, MRO approval, etc. And finally, through safety oversight. My slide is not visible?
No, sir. Actually, your slide is not visible. Can you please share it again, sir?
Just hold on.
Please share your screen again, sir. Yes, sir. Your screen is now visible, so you can start your presentation.
Is it visible now?
Yes, sir. It's visible now. You can start with your presentation, sir.
Yeah, it's kind of embarrassing today, huh? Okay, moving forward, we don't want to waste time. So type certification with respect to manned aviation involves types approval of design organization. Only a design organization approved can apply for type certificate. Approval of design organization, production organization is required for producing or manufacturing an aeronautical product. Aeronautical product includes aircraft, engine, and propeller. And very soon, when ARVAS is included, we can expect a remotely piloted station will also become a part of aeronautical product. The manufacturer is required to issue certificate of conformity for each aircraft is produced as per the type certificate, based on which the authority issues the export CFA, which enable the manufacturer to export it to other country for operation. For conducting an air operation like scheduled, non-scheduled, or aerial work, an air operator certificate is required. For that, type certificate and certificate of airworthiness are important. So this is manned aviation type certification process flow. Although this looks complicated and simple at the same time, it takes around 3 to 5 years to issue a type certificate for a manned aircraft. It depends on the level of the maturity of the applicant and the confidence of the authority on the paperwork submitted by him. When the applicant comes directly for type certificate, we advise them to get design organization approval first, so that we can assess his level of competency or capability to design an aeronautical product. After he obtains a DOA, he can apply for a type certificate for the aeronautical product. And I have explained what an aeronautical product is. Yet again, I will say aeronautical product means aircraft, engine, or propeller. And in future, there could be a remotely piloted aircraft station also. When applied, a primary meeting is set up among the applicant and Dgca. Teams are formed on either side, headed by their respective project managers. They coordinate closely and come up with certification basis, including the requirement of special conditions. So special conditions are when a novel features are there in the aircraft. So we define what a special condition is, what is the equivalent level of safety that has to be shown, what are the means of compliance that has to be shown, that will be designed, and that will become a part of the certification plan, and the timeline also specified therein. Both the team agrees the MOCs and the timeline and proceed for testing and documentation. There could be multiple of meetings, issue papers raised, generated between until the type certificate is issued. During prototype testing stage, ideally, the approved design organization will obtain the production organization approval. Sometimes design organization approval contracts out the production to another organization. In such a case, that organization will obtain the production organization approval, so that their competency is also assessed for producing the aircraft. A permit to fly is issued with limitation and condition for flight testing, and that's how prototype testing is done. Once all the issues are closed, the certification plan becomes compliance matrix with all the evidences of the in the form of annexures. This could be hundreds and thousands of pages generated over a period of time. The type certificate is issued by the authority, and the flight manuals and the other manuals are approved along with. Now, with respect to drones, we all know it comes in various sizes, shapes, and come from simple to complex and used for various purposes. Having one certification standard will not suffice, as one size does not fit all. The standard has to be simple, for common understanding, flexible, and at the same time scalable. The current certification scheme provides the certification standards for certifying a drone up to 150 kilograms, that is intended to fly in visual line of sight, day and night operation, and below 400 feet AGL only. The scheme is made flexible to allow certification above 150 grams and up to 500 grams on case by cases, and above 500 kilograms we need to follow the Aircraft Rules 1937. This implies there could be requirement for design organization approval, production organization approval, air operator certificate, etc. The scheme also specifies the method of evaluation and accreditation of the certification bodies, that is authorized testing entities, that will issue certificate of statement of conformity similar to CE marking in European Union. Now, comparing unmanned aviation with manned aviation type certification requirements, there is no concept of approval of design organization or production organization in the drone rules up to 500 kilograms maximum takeoff weight. Similar to manned aircraft, one type certificate is required per type of drone. Based on the type design, manufacturer can produce n number of drones of same type design with this statement of certificate of conformity. As you all know, there is no requirement of air operator certificate in the drone rules 2021 or certificate of airworthiness. So now the responsibility lies solely with the remote pilot who has to ensure the airworthy before each flight. JARUS, Joint Authority for Rulemaking on Unmanned Systems, was the first that floated the certification standard for unmanned aircraft system that has these certification criteria that you can see on the left. On the right, you will see the certification criteria specified in the part 3 of the certification scheme notified by the government. These, if you see, are already a trimmed down version of the JARUS CS UAS adjusted to Indian environment. Plus point, there is no destructive testing in the scheme. That means you don't have to destroy your drone to show proof of compliance. How to show compliance has been already explained in the previous session. In addition, I would strongly recommend to you all to read it once instead of believing on word of mouth. So previous speakers from QCA and certification bodies have already explained the process. I will keep it short with respect to DGCA perspective. The applicant is expected to do his homework before making an application to avoid rejections. Read the scheme, chat with us, QCI or certification bodies before making an application. Once the application is made through the Digital Sky platform, it goes to QCI currently. QCI then downloads and send it to ATEs in their own way. In near future, ATEs will be onboarded onto the Digital Sky platform. They can process the application stage 1 and stage 2, and it will, and ATE does the ATE does the stage 1 and stage 2 evaluation. DGCA team may involve in the stage 2 evaluation. Once the ATE is satisfied, they will give the recommendation to DGCA for issuance of type certificate. What DGCA team checks? DGCA team checks the application D1 form made by the applicant, the compliance matrix submitted by the ATE, and the documents referred therein, and gets the TC generated with technical specifications and put limitations and conditions in case required. What we expect from the manufacturer to show compliance is to produce each drone compliant to type design by maintaining the quality standard, rectify the in-service difficulties, and keep a track whether it is one-off or repeated in-service difficulties, to obtain recertification in case of configuration change. As a way forward, ATEs will be onboarded onto the Digital Sky platform. We will be engaging with the stakeholders for coordination, compliance, and future development and improvement, like the workshop we are having now. Assess the impact on the regulations on the ecosystem and take necessary corrective action, surveillance and safety oversight, and action will be taken on the violators. Work on BVLAW certification criteria and insertion in the certification scheme, including the real-time tracking, should be started immediately. Work on UTM and UAM certified category, that is greater than 500 kilograms, should also be started. My request to applicant is to do good paperwork using common sense. Paper should speak for itself. In DGCA, we read, please help us in achieving the ultimate goal, that is safety. My request to QCI is to develop guidance material for benefit of industry for showing compliance to the certification scheme. If we can do that in a week, would be much appreciated. Rest assured, we support growth of the drone ecosystem in addition to our primary safety objective. Thank you all for the opportunity. I'll conclude. Have a nice day.
Thank you, Mr. Tulsiraman. I suppose that was a very, very specific, but I would say very, very useful presentation in terms of compliance to the scheme requirements from the manufacturer's perspective, because you shared all the details where they can improve their function. At the same time, how CB can improve their processes and systems to comply with those requirements. And as far as QCI is concerned, what are the expectations and requirements which you have told just now? We would like to assure you that shortly we'll come out with those corrective actions and corrections, and will come out with more harmonized documents which can be used by certification bodies and manufacturers to facilitate the process. Thank you very much for this insight thoughts. Now I would like to invite Mr. Asim Datta. Mr. Asim Datta is Deputy Wireless Advisor in the WPC wing of Department of Telecommunication. Is an Indian Radio Regulatory Service officer of 2000 batch. He has worked at different levels in the WPC wing and wireless monitoring organization, discharged various responsibility, and has vast experience in the field of radio spectrum management and spectrum monitoring. So I would request Mr. Asim Datta, you please take on with your presentation. I hope Mr. Asim Datta, you are able to hear us. Ashish or Siddharth, if you can please check whether Mr. Datta is.
Yeah, good afternoon, sir. I think there may be some bandwidth issue, so I'm switching off the video. That will be better, I think. So
No
am I
issues, sir. No
audible?
issues. Yes, you are audible, sir.
Okay,
Thank
thank
you.
you, sir. So good afternoon, all distinguished guests and participants. So I am, as already been introduced, so I am working in WPC wing of DOT. So in regard to UAS and drones, we are not a major stakeholder, but still one kind of compliance requirement is there for with respect to DOT. So I'll try to explain that so that there will be clarity to the users. Just a second, I will share my presentation. Is it visible?
Yes, we can see that.
Okay. So let me introduce our wing. This is Wireless Planning and Coordination Wing. This is a dedicated wing within Department of Telecom, and you all know Ministry of Communications has two departments. One is Telecom, another is Post, and WPC wing is one of the wings of DOT, specially dedicated to spectrum management and monitoring. Now, to cut short, because most of the issues are not related to the stakeholders. So what is actually relevant to it? So I have just narrowed it down. So DOT administers 3 acts I have not mentioned two acts. So this is the act, Indian Telegraph Act of 1885, under which you require, means everybody requires a license from DOT for establishment, maintenance and working of telegraph. Now telegraph is defined in the act itself and it includes wireless telegraphy also. Means our equipment which is capable of sending or receiving any signals, means intelligence through any telecommunication medium. So we are more concerned about radio, so wireless telegraph. So wireless telegraph is those equipment which are capable of sending or receiving any intelligence over radio. Now radio is up to 3000 gigahertz, as most of you may be knowing. Gigahertz is the a bigger unit of frequency. So, and the whole spectrum we call radio spectrum. This is part of the electromagnetic wave, which is actually from 0 hertz to almost infinite, ranging to up to say X-ray kind of thing. Only a part of that is useful for radio communication. So for any establishment of a station, wireless telegraph station, one requires a license. Now, in all cases, it may not be practically feasible to grant license and it is not desired. The very basic purpose of licensing any station, particularly wireless telegraphing station, is to avoid interference. As you know, if the same frequency is used in the same geographical location by more than one users, generally there is a chance of interference. And in case of interference, you know, none of the communication will be completed, particularly for safety of life kind of services, which basically are aeronautical and maritime services, means on board ship or aircraft where safety of life is associated with it. So any interference through those communication can be very fatal. Otherwise also, any interference to public telecommunication service also may be harmful. For example, while accessing some emergency services, public health emergency services, somebody is calling to hospital and the call is disconnected due to this kind of interference, this is to be avoided. So one purpose of licensing is to regulate the use to avoid interference. There are other facets also, revenue and etc., because spectrum is a natural resource. So regulation and distribution of it should be done in a methodical manner. So basically, one of the purposes is to avoid interference. That's why we actually license, means government licenses it. But in certain cases where it is desired, where it is practically not feasible to license, we can exempt. And under Section 7 of the Telegraph Act, we, Government of India, makes a rule to exempt certain kind of frequency bands from its license exempted usages. And the most popular ones people can connect is Bluetooth, Wi-Fi, and Wi-Fi, as you know, operates in 2.4 gigahertz, which is very popular, and 5 gigahertz band. But there are so many rules, around 46 rules we have related to license exempt usages. I'm not going into details. What I want to convey, a license generally is required for any wireless telegraph station, but there are certain rules under which we exempt certain usages of frequency bands, but subject to compliance with the technical parameters notified in that rule. For example, in 2.4 gigahertz band, there is a limit of power. The maximum EIRP, that is a technical term, that is the maximum radiated power, cannot be more than 36 dBm. And these kind of restrictions are mainly done to to encourage the shared usages of spectrum and to avoid interference. Means, as you know, if power is more, then obviously the coverage will be more. And if somebody is using a particular band, then the other user may not be able to use that same frequency, say in that particular area. So by limiting the range, the redistribution of that spectrum is possible. So basically, we promote shared use, and these kind of technical parameters are specified by globally harmonizing the standards. So these are normally international standards, so that equipment can be manufactured as per those standards only, and there will be interoperability, compatibility, and everything if it is globally harmonized, if the standards are harmonized. Harmonized means when I say 36 dBm is the EIRP limit, and you will find it across all the countries. So an equipment which is manufactured in some foreign country can be used here, or a Indian manufactured product can be exported to other countries. So there will be economies of scale also. So basically license exempted is permitted in certain frequency bands, but subject to the equipment which will be operating in those bands should be complying to the technical parameters mentioned in that notification. And I quoted an example of 36 dBm. So any equipment, if it is to operate in that license exempted band, then obviously that equipment should not radiate more than 36 dBm. So how to actually ensure that? For that, although there is no licensing requirement for the end user, but the equipment must be type approved. And we issue a type approval certificate, and normally it is called ETA certificate. So ETA we issue for a particular make and model, and there is a prescribed procedure. I am not going into the details. It is available on our licensing portal. Basically, you need to have a test report, because that test report will actually certify this particular equipment is complying to a particular notification. And we accept any test report from any accredited laboratory, not necessarily Indian laboratory. So it can be a foreign laboratory too. So based on that test report, and anybody can actually obtain an ETA for a particular product, provided he has the authorization from the manufacturer. So it is primarily duty of the manufacturer to get the ETA of its product, but it can authorize some other agency also, Indian agency, to if the manufacturer doesn't have its Indian counterpart, then it can authorize somebody and they can get the ETA. And once the ETA is obtained for a particular make model of a product, then the ETA certificate is actually valid for its lifetime. So anybody can use that equipment. Not every time you require a separate ETA for the same product. And that will be coming into the next slide. And in addition to the finished product, there is a clarification we have issued in 2019. If there is an identifiable RF module, and the module is itself is used in multiple makes and models, then that you take the ETA for that identifiable RF module, and the manufacturer's declaration is normally required and that certificate kind of thing. The same module is fitted in these models, makes and models. So this has been simplified. Now, there is two kinds of basically ETA. One is self-declaration based ETA. Another is scrutiny based ETA. As you know, in 2019, there is an OAM of 26th February, by which we introduced the self-declaration ETA and made the process very simple. Now, as you can see from the slide itself, self-declaration ETA is applicable. See, there is it. Okay. So, am I audible?
Yes, you are audible.
Okay.
Pooja madam, you can unmute your mic. Mute your mic, please.
Okay.
Yeah,
So
please continue.
first condition, if you see the column number second, this is a must for both the categories. So it must comply with the respective notification. For example, when I quote 2.4 gigahertz, so 2.4 gigahertz, there is a notification number, GSN number 45E, some kind of number is there. If it is a 5.5 gigahertz relicensing, then there is a corresponding notification GSR. So whatever technical parameters is prescribed, it must comply. And who will certify? The test report will certify. So this is a common requirement for both the cases, SDETA as well as scrutiny-based ETA. Now SDETA is applicable only for those devices, means which are operating in license exempted band, but which falls under the free category of the GFT import policy. And in most of the cases in regard to RF equipment, except navigational equipment and broadcasting transmitter, most of the other devices fall under free category. And radar kind of devices, a radar as is a navigational equipment. So there is a license exempt band for automotive radar, so which doesn't fall under free category. So in that case, they will go for scrutiny based ETA. Now self-declaration is ETA. How to get it? I'm coming into the next slide. So it has been made also online the order of self-declaration ETA came in on 26 February 2019, and it was made available through online system on 12th April of 2019. So till date, around 25,000 self-declaration ETA already obtained. Now this drone and US categories, as you know, previously the policy was little different. So since it was falling under restricted category, they were not qualifying for the self-declaration ETA. Now a component, drone component has been made free has been categorized under the free category of the import policy. So accordingly, because of our policy, so they are now qualifying for the self-declaration ETA. Now, if the final built product means complete drone, if it is restricted as per the GFT policy, then one has to go for a scrutiny-based ETA. Now, till now, scrutiny-based ETA is through manual procedure, but hopefully it is in the very advanced stage. So we have asked for the developer actually to implement it in our Saral Sanchar itself. So within few months, hopefully, the scrutiny-based ETA will also be coming in the Saral Sanchar portal. So in the drop-down menu, there will be two options. One is self-declaration, and another is scrutiny-based, and there will be instruction also and user manuals also, which will be qualifying for SD and which one will be for scrutiny-based ETA. So once that is available on online, then people will will have a better experience, because scrutiny-based ETA is little difficult to get because manual procedure, and that too they have to get it from our regional licensing offices. We have 5 regional licensing offices. So I think within few months, people will even get better chances and better facilities. So this is in gist what we do in regard to ETA. So in specifically to drone, very simple. If drone component is under free category of the GFT import policy, you can take SDATA, and in SDATS there is QR code, so authenticity can be verified by the customs. And the second one, if somebody is manufacturing here itself, then also it is applicable. People come here only when customs actually do not allow to enter without some kind of import clearance or like that. But basically the requirement of ETA is for all license exempted devices, whether it is being imported or it is being manufactured here. So even if it is manufactured, ETA should be obtained. For import, along with ETA, ETA must be there for a particular product. But if a device is already type approved, not required it will every time you will take an ETA. ETA is publicly available, so anybody can use that ETA. But import also, because customs will honor the import clearance from WPC, not ETA itself. So for that, that also has also been facilitated. After self-declaration ETA, there is an import undertaking. If you see our saralsanchar.gov.in portal, you will get, if you enter into self-declaration ETA mode, after getting self-declaration ETA, you can actually generate a system-generated import undertaking by declaring your AWB number or whatever. And import undertaking, whatever will be generated, that will be honored, and that is equivalent to import clearance of WPC. So it is very simplified version of import clearance. So, and for scrutiny based ETA, you till now you require a proper import license, but we'll be making it online too. So if I summarize the thing, for drone kind of drone, if it is falling under free category, then you take self-declaration ETA. If you are importing, then after self-declaration ETA, there is an import undertaking from the system that is also self-declaration based system generated ETA, no manual intervention. And import undertaking, you submit it to the customs department. So they will honor it. And the ETA, once the ETA of a particular product or model has already been approved, then you can search it actually by giving the ETA number or by searching by the product type, for example, drone type or others type. You can get the ETA, and that ETA can be used by anybody actually, because it is ultimately the approval of the model, not necessarily the user. There is no user or licensee as such from our point of view. And scrutiny based ETA is little complicated, means little tedious, but that will be made simplified. And thank you. And I am ready to take any questions of the participants in this regard.
Thank you, Mr. Datta. I suppose it was a very detailed presentation and it has clarified a lot of query itself because there were a few queries before those clarifications and before those, I would say, communication from WPC regarding that self-declaration or whether it should be done through a security-based process or in case of drones, how these RF modules need to be taken approval from WPC with respect to ETA. But I suppose you have given a very detailed and crisp presentation, and it will be very helpful to all the manufacturers. And we see your future interventions and where you are saying that this scrutiny-based approval will be also online in near future. So all those are very, very good initiatives. And if there are certain other aspects, technical aspects where your interventions and your support and guidance is needed, QCI will definitely approach you. And I don't see right now any queries. And if there are any queries, we can take after the completion of session. So now I would like to invite
Thank you, sir.
manufacturers. Thank you, Mr. Datta. So now I would like to invite manufacturer and for example, first of all, Mr. Anup Datta, who is representing Iotech Aviation. Sorry, Mr. Anup Upadhyay. So Anup Kumar Upadhyay is basically director and co-founder of Iotech World Aviation Private Limited. He has completed MTech in electronics and communication and has worked in top-notch companies across the globe like Intel at US, and company has a manufacturing unit at Gurgaon and sales office in Pan India. Iotech develops drones mainly for agriculture sector. So I would request Mr. Anup Upadhyay to share his learnings, his experiences, that how they could develop those compliance requirements with respect to certification criteria, what challenges they have faced, and how they could overcome with those challenges. So over to Mr. Anup Upadhyay. Mr. Anup, are you there? Pooja, can you give access to Mr. Anup Upadhyay?
Sir, he's there.
Sure.
He's connected, sir.
He's connected. Okay, great, great.
Yeah. Hi, everybody. So my voice is clear?
Yes, we can hear you.
Okay. Hi, namaskar, everybody. This is Anup Kumar Upadhyay, and so I am from Iotech World Aviation Private Limited, Gurgaon, and you all are aware that we are the first company who got the Dgca approval under the Drone Rule 2021, right? So first of all, I would like to thank QCI for providing me this platform to share our feedback with the industry so that we can help in a way for other manufacturers to also apply and get the QCA certification. So let me try to present, and give a brief introduction about the company and what was the process that we followed and what are the feedback so that, other manufacturer can also, get the certification. So let me know, I'm sharing. You guys are able to see my presentation. Are you able to see my presentation?
Yeah, it's getting displayed. Yeah, now we can see.
Anup, you're on mute. Please unmute yourself.
Okay. So I'm trying to share. Okay. My slide is not moving. I don't know why. Can you give me control? My slide is not moving somehow.
We can see your slides, Anu.
Okay. I wanted to go to slide 1, but somehow it is not moving.
So, Anup, you can try to reshare your screen and then project the slides again. I hope that would solve the issue.
It's stuck.
कोई बात नहीं अनूप जी, आप एक काम करिए कि आप कंटिन्यू करिए और you can continue with your here.
Okay, so so this is the small roadmap that when we incorporated the company, so it is like 2017 we started the company. Then 2018 we developed the agriculture drone for applications like agriculture, survey, logistics. And 2019 we got the Dgca approval, provisional approval for AgriBot. And then we became part of the drone policy because we were so we have to work in conjunction with Dgca and also Ministry of Agriculture to open the policy, right? So that is one of the things that we did during 2019 timeframe. And then in 2020, we got associated with Haryana Agriculture University, Punjab Agriculture University, and also we got tender award from DRDO, Ministry of Agriculture and Farm Welfare. Because we started collaborating with the university drone and try to find out the efficacy, whether there is a phytotoxicity or not. And then, so after getting a very promising result, then we go back to Ministry of Agriculture and then submitted the report, presented in front of the committee. So obviously IRI was one of the leading, universities who took the initiative. Then dealer distributor network we set up in India to proliferate technology up to the farmer level. And during that time frame, Ministry of Agriculture and Farm Welfare also released the SOP where they allowed spraying, aerial spraying using drone, right? Because earlier aerial spraying was banned in India. But by using drone, we put the case and said, okay, we are going to fly just 2 meters above the crop canopy. Then ministers and scientists, they agreed. And looking at the ROI, the benefit that drone technology is going to provide in the agriculture sector, they agreed and they released the SOP. 2022 AgriBot, we got the drone approval under the rule drone 2021, as you all are aware. And we are also trying to develop, since our target customer is farmers, so they always talk in their local language. So we are also developing all the GUIs in UI UX, and also we are trying to bring drone on a bike because transportation will become easier. In 2023, we want to indigenize a lot of the components so that our import dependency reduces and we control the quality, cost, and delivery, right? So that is our motive as an Iotech, and then expand the dealer and distributor network. So this is, can we move to next slide? Somehow just, let me try to share once again. I'm trying to share. Let me know if you guys are able to see.
We can see only the slide number 2.
Yeah, that is why the slides are not moving. So
okay,
sure.
Okay. So
just give me one moment.
Okay, please go ahead.
Somehow, I don't know.
Okay, so what you can do, you please continue with your presentation through verbal
So
mode.
now, are you guys able to see presentation? I'm sharing now.
We can, yeah, we can see presentation, but we can see only the slide number 2.
Now also I'm sharing.
Just a minute.
Anup,
Now are you able to
try
see?
to go on the presentation mode. Start your presentation and then try to move slides. You're just sharing one window at the moment. So go on the presentation mode.
Presentation mode. Okay. Stop.
Like,
So do I
put it
need
on
to
a
go?
slideshow. Put it on a slideshow.
Slideshow where means like there is a a camera, mic, then show participant, conversation, hand, and then where I need to go. Can you help me?
Anup, you can press F5.
F5. Okay. No, it's not working somehow.
I think your screen is freezed.
कोई बात नहीं अनूप जी आप एक काम करिए कि आप प्लीज
So Marshall,
कंटिन्यू
I have
करिए.
shared the slides with you. Can you post? Somehow it is not working at my end. Now you are able to see?
Yes.
Yes, now we can see.
Now are you able to see?
Yes, now we can see that you can continue.
Anup, we can see your slides. Please start with your presentation. Anup, can you hear me? You're on mute, Anup.
Are you guys able to hear me?
You're not audible, Anup.
No, now we can hear you. You please continue with your presentation. We can see your presentation as well. You can please continue.
Are you able to hear me?
Yes, sir.
Yes, Anup ji, we can hear you. You please continue.
Anup, hi sir, Marshall this side. Sir, I will share my screen for your PPTs and you kindly continue with that.
Are you able to hear me now?
Yes, sir, we are able to hear you. I am saying that I will share my screen and you can continue with that, your presentation.
Are you able to hear me?
Yes, sir.
Yes, we can hear you.
Sir, Marshall has shared his screen. Your presentation is on. So, sir, you can speak.
Anup ji, we can hear you.
Okay.
Please continue.
So you guys are able to hear me?
Yes,
Yeah.
yes.
Yeah, sure. Thank you. Yeah, go to the slide number 3. Yeah, second. Yeah. So we are two founders. So my name is Anup Kumar Padya and Deepak Bharadwaj. So we have relocated from outside India and started this company and wanted to stay legally because we wanted to have a long vision in business. So we wanted to stay legal. So we have mixed flavor of from automotive industry and electronic industry, and so that's it. So can you move to the next slide? Yeah. So what does this agribot does? So we know there is a lot of problem happening in the agriculture sector. So there is a shortage of labor, and when we do a lot of spraying, then what happens? There is a lot of health issues. Our farmer friends are directly exposed to the harmful chemicals, as you can see in the picture. And it is a very, laborious process. Sometimes it becomes very inhuman, because when the crop size becomes long, then it becomes very bushy, thorny. So it's going inside is very difficult. And it is also very less efficient and time consuming, because to cover 1 acre of a single farmer needs 5 to 6 hours. And sometimes it is very dangerous also, mainly in the fields of paddy, when there is a water logging, you know. And then there are a lot of wastage. We need a lot of water. Let us right now, with using knapsack sprayer and tractor mounted sprayer, we need almost 200 liters of water. 1 kg chemical is diluted in 200 liters of water. And then it's not a very optimal use of our natural resources. So, and then in India, if you look at the demography of India, agriculture demography, so there are a lot of farmers, small and marginal farmers, who holds less than 1 acre of land. So 85% of population is for small and marginal farmer, right? And then India has a variable terrain in the climatical conditions from north to south, east to west. You see there is a lot of difference, as far as terrains are concerned, as far as climatical conditions are concerned. So there is a lot of challenge that we try to see. And we wanted to work, when we relocate from outside. So we wanted to work and take up an application where there is a social economical benefit to the society, right? So that is one of the reasons why we selected the agriculture sector, and where we thought if we could do some innovation in spraying and try to bring the robotics in agriculture, that will help our farmer friends to increase the yield. So that was our motivation before behind developing the agriculture drone. Next slide, please. Yeah, so this is the drone by name AgriBot. Okay, so this is less than 25 kg. And so this is a multi-purpose drone basically. So it does spraying, and it also does seed broadcasting, and it also does crop health monitoring. So when we took the approval, because the variable payload is allowed, then we put up a case where we said configuration 1 is only for spraying, where you can put a 10 liter of a solution, and then you can spray in 1 acre of land. So that is the first configuration set. Second configuration is where a broadcaster, right? So second picture on the right, you will see that is a broadcaster, right? So that instead of filling the liquid, you put urea or seed granules, and then you control the speed of broadcaster, impeller, and then you can spread the granules in the field, right? So we try to make this drone as a multi-purpose drone, so that the ROI for a farmer increases. So it's is a simple process. You have to just remove the cap, put the broadcaster, and it's a very simple electrical connection. And all other the configuration, the type, and the body, the center of gravity, everything remains same. The only small change is the broadcaster. Then at certain point of time, it's very difficult for a farmer to always spray in the field. So if you take a typical crop cycle, there are only 5 cycles. If you take a paddy, right, from germination to fruitation, there are only 5 spraying that happens. So what will this drone will do the remaining time, right? So what we did is we put a multispectral camera. So, right. So he can also do crop health monitoring, crop estimation, yield estimation, and what is the impact on the, whether there is a stress level, what is the thermal level of the crop, temperature level, how much how much field is left unplanted. Then that also can be, captured after doing the software analysis on the multispectral camera. So multispectral camera, there are 5 bands: RGB, near infrared, and red edge. So once the data we collect in the SD card, then we process it through the software, and after running the analytics, we get all these 5 components and try to do focus spraying. So that is a new technology that is evolving, not widely used. Only it is used in agriculture university as of now. But that is a future, where rather than spraying in the whole field, we want to spray only in the targeted area where the infestation is there. So that is a future technology. So this drone is not only going to help the current problem in the spraying, agriculture spraying, but it is also going to provide a capability for future analysis, for our scientists, for our progressive farmer friends. Next slide, please. Yeah, so this is a very small video that I try to capture in the spraying. So there is a radar, there is a lidar. So this, agriculture drone is going to fly at a very lower height, less than 5 meter, because as per Ministry of Agriculture, they have restricted that we should not fly a drone 3 meter above the crop canopy to restrict the drift in the chemical, right? So we need to follow that. And apart from that, there is a radar. So that it's not lidar, it's a radar. So this is probably one of the few drones in India which has a radar technology implemented for collision avoidance and detection, and also for terrain following, right? So this is a hexacopter, 10-liter tank capacity, and by using multiple batteries, you can cover easily 30 acres per day. And its radio video telemetry is up to 500 meter, right? Time of flight is 20 meter, up to 20 meter, depending upon the terrain. If you have a lot of obstacles in your field, then definitely the time of flight will be less and drone will try to navigate through the obstacle while avoiding the collision, right? So it all depends upon the geography of the field, but easily with one set of battery, you can cover 2 acres, 10-liter spray per acre. So feature wise, it has semi-autonomous mode. Then it has collision avoidance, terrain following, return to launch, and there is an FPV and smart range battery fail safe. There is a new feature that we have put in our intelligent drone. So benefits, so there are a lot of benefits, is completely made in India. Dgca norms compliant, right? Because we have to follow all the legal compliances. And plant protection, chemical spray, nutrients, granular fertilizer, broadcasting, mosquito larvicide control, outbreak control, locust, reforestation, seed broadcasting. So these are the typical applications of AgriBot around which we have made this drone. And so once we develop the drone, we also need to provide services, hand holding, pilot licensing, insurance, UIN number, right? So we have to help our customer to get all these facilities on the drone. So they cannot just go and fly like that, right? So there are other legal compliances also we need to meet, right? So there should be a third party insurance, a drone insurance, right? A pilot should be trained properly. And this, so it's not only, a pilot should be aware of all the civil aviation, security rules and regulation. Since this is an agriculture drone, so he should also be aware of the best practices that we follow in agriculture, right? For an example, like when he has to make the solution, how to read the label, what should be the dilution level, so all these things also we train our customers before delivering the drone. Next slide, please. Okay, so this was for a brief introduction about the company and the product, and so since we got the certification, so I would like to share some of the learning during the journey, and also give some of the feedback to all my manufacturer colleagues, so that they should not face all the difficulties and the process becomes very easy for everybody, right? So first of all, my recommendation will be refer Drone Rule 2021 line by line and clarify all your doubts before starting the documents, right? So if you remember how we started doing preparation is we have attended all the webinars like this, which QCI has organized, and we were not feeling shy asking all our doubts. So most of the time what happens is people, they attend the webinars, but they feel shy, or sometimes they hesitate to ask question, thinking what others will think if it is a silly question. So don't think like that. You have to understand, you have to clarify each and every doubt before you file the document. Friends, it is not an easy process. There are 6 to 7 agencies involved when they award a certification. So be clear, everybody will follow this document, whether it is DGCA, MOCA, QCI, CB, labs, or whoever, WPC. So they will refer the document. So as a manufacturer, you should have clarity line by line. Refer the webinar and FAQs posted at QCI website. So there are a lot of questions on the battery performance. I was hearing today meeting. So people have, all the stakeholders have shared a lot of very good information. Whereas sometimes what happens, it becomes very difficult for the presenter to answer all the questions that has been posted. So what I would request to manufacturers is please refer FAQs, go to QCI website, get in touch with the concerned person. Let us say if you have some doubt on battery, go and talk to a QCI stakeholder, ask to arrange a meeting if you need, refer the FAQs, but get your answers, before filing the application. If you have a doubt, then you will not be able to convince to your, certifying body or whoever is going to come and, verify your drone, whether it is a stage 1 or stage 2 process. Prerequisite. So before filing an application on the Digital Sky platform, there are some prerequisites that you should do, right? You should have an ETA, get the BIS, get all the reports like EMI, EMC report, environment report, performance lab report, and this after successful test. So try to arrange all these documents before you file and prepare documents for the application. So these are prerequisites. Prepare document with proper revision control. Yes, this is very important. Revision control and stakeholder names, like who has prepared the document, who has verified that document, and and who has approved that document with time and history. So this is very important, because what we have noticed is even though you are going to make a change, people will ask, okay, which revision number, which page number. So be very particular, in the documentation, make proper page numbers and everything, So it's for your benefit and it's benefit for other stakeholders as well. So there are a few recommendations that I would like to give, from our learning. I may be wrong. So if it is applicable, please take it up. Otherwise, just drop it. Manufacturers should be present at least in the first meeting with CB, giving briefing to Dgca. So sometimes what happens, there is no direct connection right now. So earlier in provisional certification, a manufacturer was directly talking to Dgca. But now what happens is the manufacturer, then CB, then QCI, and then Dgca. So there is a hierarchy, So sometimes what happens is whatever you are trying to explain on a particular feature. So it all depends upon, it's not only the capability of a manufacturer, but it also depends upon the capability of the listener, means how much you are explaining, how much he is able to grasp, So sometimes what happens is you try to, tell 100%, it reaches 50% to next level, 25 to next, and then, 12.5 to next. So sometimes ball gets dropped in between. So try to I would request to invite manufacturer at least in the first meeting during the debriefing with the Dgca. I understand manufacturer cannot be involved in all the meetings, but at least in the first meeting where he tells about, and if any doubt happens, then he can clarify then and there. Compatible payload details with weight should be mentioned clearly with integration challenges, if any. So yeah, if your UAV is going to support compatible payloads, then you have to give very clear detail, even the component wise, what is the base model weight, then what is the weight of the payload in different configurations. So this is very much required, and ensure that the weighing machine that you are using, it should be properly calibrated and it has the certificate, So for its substantiation, whatever you are claiming, that needs to be verified properly from a well-calibrated machine, and that certification is also required for a manufacturer to be submitted. One of the very strong recommendation we would like to give to industries, compliance matrix should be filled by manufacturer rather than CB with proper pointers to reference document and clause detail, page number detail, etc. What happens is there are 6 to 7 people involved who will be referring to your documents, right? So there is a compliance matrix, as we all know. So try to, against each and every item number, whether you are meeting or not. If you are not meeting, and not applicable. If you are meeting, then you have to tell, okay, where is that information provided, how you have substantiated. For example, let us say I'm saying that the particular weight of the drone is, let us say, 24 kg, right? So how I'm substantiating? Where is the proof? So which document, which page number? So you have to point very specifically so that people should not go and read each and every document. Rather, they should just go look at that particular clause and get the answer. So it saves your life also, and it saves even the reviewer life also, because if it is clearly pointed out, then they will be very happy and they will not trouble you. Otherwise, if there is lack of clarity, then same people will ask again and again the question. So it's very, I would advise all the manufacturer to fill the compliance matrix. Next slide, please. So that's it. I'm not a very big expert. Yes, we become the first to qualify, but there are a lot of learning, still learning. So I'm still learning, but I try to share whatever I've learned during the process of development. Thank you.
Thank you, Anitji. I suppose it was a very, very good presentation where you could highlighted the core areas where manufacturer can take inputs from your learnings, and they can implement those learnings in their processes while they are going for D1 application form. And you were very, very specific in terms of certain requirements, whether certain test requirements, documents requirements, or how to fill up that CRM form. So thank you very much for sharing those learnings, and I'm sure that our manufacturers and potential applicants will get benefit from those learnings. Now I would like to invite Mr. Sai. Mr. Sai is representing Crystal Ball. He is basically a products and solution lead, and he's an aerospace engineering alumni of IIT Hyderabad. He has been passionate about aviation from young age and has started the Aero Club in IIT Hyderabad. As a founding member of Crystal Ball, he contributes towards customer solutions, product design, and leads the area of compliance. So, Sai, I would hand over to you.
Good afternoon, everyone. I hope you all can hear me. Firstly, I would like to thank the QCI for giving this opportunity to talk on behalf of all the manufacturers and our company. It's been a very interesting and exciting journey for us. We were the first pilot project for QCI as well, and our journey started almost 18 months ago. And there were a lot of challenges where all the forces were united to overcome the challenges, like the BIS on the battery, or the new addition to the battery requirement, or the ETA, where we've got immense support from QCI, DFI, Dgca, and everyone. So I would like to make it very short and crisp, and I have a small presentation to share. I'll be just sharing the screen in a minute. I hope you all can see the screen now. Crystal Ball is a global startup headquartered in California. We have offices in India and Hyderabad. We are incubated by IIT Hyderabad, one of the leading educational institutes, ranked almost 7 consistently for the last 4 years in NIRF rankings. All the technology development happens at the moment from our IIT Hyderabad office. Our mission is to become a global leader in providing fastest insight delivery service. So we were the pilot project for QCI, and this is the product that we've got certificate, type certificate today, actually. The product is Model V, and the applications are mainly mapping, crop inspection, and surveillance. So without wasting much of the time, I would like to give my perspective on advising my fellow manufacturers what can be done best for successful compliance in the quickest manner. And this is strictly from Crystal Ball's perspective. I would say 3 key points are essential for all the manufacturers to keep in mind in order for them to comply with the criteria quickest, and then make sure that there are no hassles in the certification process. They are the following. Number 1 is understanding the compliance criteria as per CSUS scheme 2022, and understanding how to comply once you understand the compliance criteria, where testing needs to be done, and what are the standards and guidelines one needs to follow. And lastly, and most importantly, making sure that all the documents are crisp, organized, and traceable. We'll get into them in details in the coming slides. The first one is understanding the compliance criteria. Like our friend Anup Upadhyaya said, and there were a lot of webinars and seminars organized by QC on the same. It is very, very important for all the manufacturers to understand the compliance criteria end to end. What I mean by that, there is a clear-cut document available in the DGCA website under CSUS Scheme 2022, which was released on January 26th. You need to go through that line by line and understand it word by word. And if you have any questions, the QCI team is always approachable. There are already FAQs designed on how to apply, where to apply, and what are the specific challenging areas like the BS compliance for the batteries or the ETA, regularly posted by QCI on the website. So without understanding the compliance criteria, it is very difficult for manufacturer to proceed to any further step. So this is the first step I would advise all the manufacturers to understand all these 10 chapters, starting from your general structures, power plant, materials, data link to end of documentation to understand it. The second one is understanding how to comply. Now, QCI and the team has done a great job in putting a column on means of compliance and method of evaluation in the same scheme, which helps the manufacturers understanding what are the guidelines that the testing needs to be done, whether it needs to be done in any well accredited laboratory or manufacturer's testing is good enough. So all the details are clearly mentioned there, and also the standards and guidelines are mentioned there. What do I mean by that? There is a specific standard associated with each compliance criteria, if there is, and the specifications were given in the same column. Now the manufacturer, what is expected of a manufacturer like us to go through that and to identify which NABL accredited laboratories testing needs to be done. For this also there's a good link in QCI website to search all the NABL accredited labs based on the testing that you need to do. And the second thing is, even though you understood the standards which were mentioned, the testing might be specific to your product, which could be your performance testing or it could be your battery testing, which are very specific to your product, and it is not covered in the standard guidelines. There you need to understand very clearly what exactly you need to do. And the third one is, and which is also the most important thing, is making sure your documents are crisp, organized, and traceable. What do I mean by that? When you are first interacting or submitting your D1 form, you'll be submitting only your documents and nothing else. So the body who is evaluating, which is the ATE or QCI or DGCA, they will not be looking at your drone model or your drone videos or photos. For the first thing that they would look at is documents. So make sure your documents are crisp, organized, and traceable. Make sure you have proper revision control, like our dear friend Anup Upadhyaya already mentioned. Make sure that all the revision history is there, so that when there is a change in the document, it is documented accordingly, and when an audit is done, you can produce the previous versions as well. And make sure you are giving references for all the documents in a very clear manner. For example, you're demonstrating compliance on chapter 2, section 2.1. What are the documents which are required to demonstrate that compliance has to be very clearly organized, and the document's name should be filled in the compliance matrix by the manufacturer. What is compliance matrix? I think many of you have already known, but for those who don't know, compliance matrix is a accumulation of all the 10 chapters into a single table, where the manufacturer will be demonstrating the compliance against each column. And this table will be the first and foremost reference for all the certifying agencies and regulatory bodies to look at your case. So all the details that you're mentioning in this compliance matrix has to be really crisp, and documents have to be traceable and organized. So this is what I would like to quickly advise all my fellow manufacturers. And if you have any specific queries, you can always reach out to QCI, or you can reach out to us as well. And as a fellow friend, I would be able to help you with the best advice I can give you. And this is the quick team, our core team. I would like to introduce our founder Sandeep Reddy, and the development team Vidya Sagar and myself, and our operational state Vikram. And I would like to thank you all once again for giving me this opportunity to speak and represent the industry. And thanks.
Thank you, Sai, for this nice presentation. And I understand that most of the point which has shared by Mr. Anu has been echoed by you. So it would be a good idea to take a note of those learnings from all the manufacturers and applicants, so that they can quickly adopt to those requirements, and they can submit their D1 forms in line with those compliances. Now I would like to again invite Mr. Smith Shah, who is a known face in drone fraternity, and I would like to request if he can share his experiences, his learnings, and what are the initiatives as an industry they are taking in future to take up those challenges which have been faced in earlier times, and what are the new initiatives with respect to technological interventions. So I would like to invite Mr. Smith Shah.
Thank you so much, CS. I hope most of the points have been covered by my friends Anup and Sai. Just wanted to cover a few more points on the data that has been not captured in the presentations uh, until now. Just allow me one moment. So we haven't covered any discussion around the other documents that need to come with the product, which is the flight manual, product manual, and the maintenance manual. So just wanted to mention a quick few points around the same before we talk about the general interventions. So along with all the certification documents, the product manual or the flight manual is also an important document. This is essentially a document that is going to explain the basic features of the product as well as various other standard specifications and operating criteria. Once the product is going to be sold in large numbers, it is going to be very difficult for product specific training to be given to the end customer. From the regulatory perspective, a drone that is to be bought has to be type certified, and the person who is flying the drone has to be having a remote pilot certificate, which means that he may be aware of how to fly a drone generally, but the person may not be specifically aware about the product features or the drone that he's going to buy. So that is where the product manual becomes very important, as well as the maintenance manual. Some more details around the same. So what can a product and a flight manual cover? Basic photographs of the product, the assembly as well as storage procedures in case you have a drone that folds and it needs to be opened up and it needs to be folded again for storage, or some parts need to be disassembled. Then those various procedures as well as their diagrams. Basically everything that a customer needs to do with your product and is going to help them manage the product is all of these details need to be taken care of. Of course, the detailed specifications of the drone as well as the performance characteristics, which means the weight, various payloads that are compatible and that can be attached, various performance limits like range, endurance, the battery related thresholds and all of that. So these are things that need to be covered. The ideal operating conditions and the limitations, what temperature, what altitude, and what kind of environments can the drone be operated in, whether, how much wind resistance has to be taken into account, in case some minimum number of GPS satellites need to be checked before taking off, and various other environmental parameters as well. So all these need to be mentioned as ideal operating conditions or limitations, so that we can ensure normal and safe operations. The various pre-flight and post-flight checks that need to be done and the procedures. So before every flight, in case the manufacturer recommends as a part of safety, every manufacturer should recommend. But inspection of propellers, the mounting of the propeller, whether there is any dust around the motors or not, whether the battery and its plug has been properly clipped on and is secure or not. So there are various pre-flight and post-flight checks. The pre-flight checks will usually amount to the procedures that are going to allow whether the drone is safe to fly or not. And once the operation has been conducted, whether there are any damages or not, those criteria will be around post-flight check. So these things need to be undertaken. And the normal operating controls as well as procedures. So what are the different types of screens, menu items, what can be customized. All of these need to be looked at. As simple as whenever we buy any electronic appliance or a car, there is a manual that comes in that explains all the features of the product. Something similar needs to be prepared and needs to be made available for the customers, so that they are not directly dependent on the manufacturer and they can take the full advantage of the drone that they can sort of take, and while being under the normal limitations and the procedures. Lastly, the product manual should also mention a bit details about the emergency procedures. So in case of battery failure, in case of communication failure, what buttons need to be pressed, how will the drone behave. All of this, of course, the manufacturer showcases this to the certification body, but the explanation of all of this also needs to be put into the product manual. So that's the few things. In the maintenance manual, again, this manual can be combined with the original product, or it can be can be combined with the as a separate document as well. That will involve again pre-flight, post-flight, and regular maintenance procedures and various diagrams associated with the same. So before each flight, what needs to be done, after each flight, what needs to be done, and in a period of, let's say, a few operations or a periodic time, what all needs to be done. These are the details that need to be looked at. And there should be key personnel like helplines or maintenance personnel, and their contact number should be available in all of these manuals. So in case something goes wrong, from the manufacturer side, who to contact. Those are certain details that need to be brought in the various manuals. Another document that can be provided is a logbook. So every pilot, once they are flying the drone, they may start monitoring their logs. So for this, a logbook can be provided, as well as the logbook can have certain number of pages for maintenance log. So every time the drone is going to be maintained either by the customer themselves, or they are brought in for regular maintenance to the manufacturer, the records can be maintained together in a flight log plus maintenance logbook. So these are certain documents that can be captured. So this is one point that was missing in the discussion. So I thought maybe it will be important to cover it. A further set of interventions, a lot of manufacturers are now in the process of getting the type certificate, as well as two manufacturers have got the type certificate. So we are in the process of working with all of them and leveraging the learnings and trying to publish some sort of guidance material. The idea is not to sort of create any formal document that can be recognized officially, but what we have seen is that most manufacturers actually have all the technical understanding of what needs to be done, which means they know how to do the compliance. In most of the cases, they don't know what compliance to do. So if there is a clause that is written, most manufacturers know how to do design simulation, how to calculate center of gravity and various other aspects. But sometimes they don't know whether they are supposed to write a sentence, write a paragraph, create a detailed set of analysis, perform some sort of a design uh, simulation. So what out of this? So we are trying to create certain standard explanations. So in case you need to comply to a clause, what all can be done? And of course, the same will be shared in the public domain. So everyone can take leverage out of that. So this is certain interventions that we are trying to bring in, so that certain common formats or common understandings can be created. And it is easier for all manufacturers to keep following at least the minimum amount of thresholds, and there is less ambiguity and less burden on the certification body as well as the QCI team as well as DGCA. Of course, all of them can come up and can keep reviewing each case and keep giving fantastic inputs. But we believe that the most basic things have to be understood by the manufacturers, and the basic information should be available in the public domain and it should be democratized. So with that kept in mind, we are in the process of making sure that all the basic information that a manufacturer should anyways know, we can make it available for everyone and that can be consumed. And we believe that that will help all the concerned stakeholders, which is certification body, QCI and DGCA, give more valuable inputs rather than repetitive inputs. So we want to ensure that the repetitive inputs can be cut out and everyone can keep spending more time in creating more value. So that is a few things that we as DFI, along with some of the manufacturers, are in process, and we'll keep everyone posted and we'll make sure that we are able to share these learnings in a documented fashion as soon as possible. That's it from my side. Thank you, CS, for giving me the opportunity to moderate the previous session as well. And we hope that we are able to contribute to this effort of QCI and DGCA. And a special mention to Manish Pandey, CS, and all of the other stakeholders of QCI for continuing to host these sessions repeatedly. Repeated sessions ensure that a lot of people are able to join and they're able to learn from the queries that other manufacturers or other stakeholders are also asking. And this kind of a publicly available interaction will help a lot of people solve a lot of queries and become more strengthened in terms of the knowledge and make sure that they are able to apply very quickly and in a more comprehensive manner to the certification scheme. Thank you so much for giving me this opportunity.
Thank you, Smith. Thank you very much. And I understand that you are one of the core pillar of this entire ecosystem. And whatever the initiatives you are going to take, that will definitely help the industry. For example, you talked about that informal guidelines may be circulated down the level. So that will definitely going to help all the manufacturers in near future. And after that, I would like to propose a short presentation from Mr. Guru Veappan. Mr. Guru has recently joined Quality Council of India in PMU. He has got more than 150 hours of experience in BVLOS applications exclusively in logistics deliverables via drones. And I would request Guru if he can highlight some future initiatives which QCI is planning to take in terms of modification and upgradation in the scheme. So he can highlight those areas. One disclaimer is there that whatever we are talking right now, those are in the initial phase of drafting or taking inputs from various stakeholders. So nothing has been freezed. And there is a proper consultation process through which we will take inputs from various stakeholders, whether manufacturers, academia, regulators, DGCA or MOCA. So we'll take formal and informal inputs on all those aspects which Guru is supposed to discuss. And once those formal inputs are being consolidated in a structured way, those will be routed through our various committees. So now I would request Guru to take it further.
Hello everyone. Good evening. Like CSR informed, let's look at the way forward for BVLOS operation and autonomous systems. At QCI, the governing structures of certification scheme for unmanned aircraft systems have a multi-stakeholder steering committee at the apex level, supported by a technical committee and a certification committee, each with its secretary in the QCI. We are engaging with more stakeholders to understand their needs and expectations and exploring best global practices and standards in quality ecosystem for drones like Sora and Jara. Periodic review and monitoring of the implementation of the scheme required to have prompt corrective measure to improve the process. Now moving forward to the beyond visual line of sight application. Usually people are not aware what is the actual BVLOS operation is. The difference between VLOS, visual line of sight, and the BVLOS is that beyond visual line of sight, there will be no visual observer. Therefore, within the calculated energy available from the battery, stability of the flight controller design is the key for the safe and successful completion of the flight mission. Nowadays, long-range flights are needed for various operations such as logistics, wide area surveillance, and search and rescue for people in distress. The key to these operations is the control technology for DVLOS. For autonomous travel by the drone, the key is the flight controller. The present scheme caters to check all the mechanical and software parts within the endurance capacity of the drone. But For BVLOS, the drone within the same parameter is expected to complete a safe mission autonomously and without any input from the pilot. So the flight controller and the navigation system of the drone must be tested with some kind of standards or equivalent to DO178 or DO254, which is if cleared by the autopilot company, will ensure the reliability and the robustness of the system, entire system. So the team of experts decide stability of the flight test for acceptable industry recognized autopilots. We are encouraging companies to choose from flight controllers which are already DO standard certified. Encouraging software system requirements and minimum number of flight hours like 50 flight logs, documents to be submitted as evidence for a flight controller carrying out the type BVLOS mission on the specific type of the drone. This would help us analyze how the operation is going on in the current scenario. And the data link as per specification to be checked, since any loss of data link activates the flight controller. Reliable communication technology and advanced sensing technology are needed to ensure safe and reliable operations in BVLOS. The manufacturer shall focus on developing reliable and safe, detect and avoid, and detect and navigate and emergency landing technology inbuilt in their systems so that it can be easily compliant with the coming up frameworks which we are doing internally. The drone shall have a parachute and ADSB out, which should work in combination with the UTM to ensure a safe mission. If this is implemented, there will be no hassle for any operation in the future. This requirement has to be decided by DGCA for all BVLOS operations. Once the requirements is made mandatory, the aspect should be checked for function and performance by certifying bodies. Now, talking about BVLOS operation, the key is the autopilot. When we talk about autopilot, the autonomous mission is what is the thing which we are looking at. Say ready or not, UAS are set to significantly impact our society, especially with the integration of artificial intelligence, computer vision, and machine learning. Drones are extraordinary in that they can operate in countless business industries and functions, including construction, real estate, indoor and outdoor inspection, surveying, site selection, agriculture, and delivery of consumer goods, logistics, and medical supplies. As AI is added to the drones, the world will watch as they intelligently interact with their surrounding in areas where it is dangerous, impossible, out of the way, or time consuming for humans. Overcoming these challenges with choosing the right brain, which is basically the artificial intelligence. There are various levels of drone autonomy. For BVLOS operation, the least we could recommend is level 3 and level 4 and level 5. Level 3 drones are pilot in the loop, like conditional human intervention. When you're operating a level 3 drone, automated drone process are in a common place. Consider, for example, when a drone pilot or operator programs a flight path using traditional automation tools, such as waypoints and geofencing to direct a drone from moving from point A to point B, the drone flies automatically using an array of sensors, timers, motors, and other electrical components. Although the process can be proceed without further input a user can step in at any point to tweak the machine or cancel it altogether. So there should be a pilot always be in the loop for this kind of for this kind of operations, and which is not feasible for us in the future when it comes to BVLOS operation. Coming to the level 4 drone, which is highly autonomy, but even in those highly autonomous drones, humans should always keep monitoring what is happening with the help of UTM. Like say a drone which have a high level of autonomy, in that they use advanced detect and avoid system and detect and navigate system without any pilot action. One pilot will be able to manage many BVLOS operations simultaneously. For example, Zipline has scaled up to 24 drones in one fleet under the command of a single operator in Africa. They are adopting the software, the technology, the artificial intelligence that are required to moving forward. So, like in India, we need to level up, and we are recommending manufacturer to produce a quality, reliability, and safe operation, safe and secure operation point of view drone, which comes to the level 5 complete autonomy drone, like where there is zero human interaction, like in the movies. Autonomous drone process are difficult in that an autonomous drone can make some decision without user input. This is possible through AI systems that gather data from sensors, satellites, camera, and video, and then use their data to make decisions. These drones' decision making process isn't confined to an algorithm. Instead, an autonomous drone can learn from its own environment and adapt to the challenging situation, which is what we are looking for to happen in India. Thank you.
Thank you, Guru. I suppose it was a very good presentation on what we are looking for in future with respect to updation in the scheme and what new technological intervention we would like to have in the drone sector. Definitely, it's in the nascent phase, and we have to get a lot of inputs and value additions from different stakeholders, including those experts who are working in this domain since long. And we'll formalize all those inputs, and then we'll proceed further with the help of our regulators like Dgca and other stakeholders. So thank you very much for this nice presentation. Now, I would like to open the session for Q&A. And if there are any questions, we can take those queries. Marshall, can you help with that? Yeah.
Yes, sir. Kindly put questions on the Please write out queries on chat box. I think, sir, people are not dropping the queries in the chat box.
Yeah, that may be due to the reason that our presentation was quite elaborate on certain aspects, and we have also handled intermediate queries which we have received in the chat box. And if there are no further queries, we can proceed as per the planned agenda. And if there are certain queries which they may ask in future as well, you can mention those of our contact details in the chat box, and those queries can be taken further. So now I would request yeah, Ms. Pooja Shukla to
Yes, sir.
it further.
Thank you. Before we move ahead, let me thank our moderator, Mr. Sharma, and the speakers, Mr. Tulsi Raman, Mr. Ashim Datta, Mr. Smith Shah, Mr. Anup Upadhyay, Mr. Sai, and Mr. Guru Vayu Rapan for sharing their thoughts. So, friends, with this, we are now come at the closing of today's conclave, and it's time now for the vote of thanks. However, before we move ahead to the vote of thanks, I would like to inform that we will be sharing a feedback form on email. Request everyone to spare some time and provide your feedback because your feedback is valuable to us. With this, let me invite and welcome Mr. C.K. Biswas for the vote of thanks. Over to you, sir.
Sir, you are on mute, sir.
Oh, it went on mute. Okay.
Sir, you are audible now.
Yeah, okay. Fine, it's fine now. Okay, so good afternoon, everybody. I'm C.K. Bishwas, and I look after the National Board for Quality Promotion. That is NBQP in short, and it's an integral board of the Quality Council of India, which was incepted in 1997 January. It's dedicated for promoting quality primarily in the manufacturing and service sectors with the mission statement to be a catalyst for the promotion of quality movement amongst all stakeholders. NBQP organizes events such as quality conclaves, workshops, awareness programs, conclaves like this one, and quality month competitions. It has instituted various award schemes like UCI Dear Shah Professor S.K. Joshi Lab Excellence Awards, Quality Champion Award, as well as it has collaborated with OPPI and EPC for their awards, and it's working towards instituting more quality awards. It motivates the industry to upgrade, enhance the processes through the application of appropriate quality tools and techniques. This board also provides technical support to both central state government departments and PSUs for implementing the ISO 9001, 50001, 45001 standards, as well as in undertaking process improvement projects through Kaizen Lean 5S methodology. And it also does assessments in various fields, especially the trainings conducted. It operates a registration scheme for consultants, auditors, management scheme, courses, as well as individual corporate professional membership schemes. Today, we have had an eventful day, and with all the eminent speakers giving an insight and effort, which was made to bring together the key stakeholders of the UAS industry on a common platform, providing them with an opportunity to share and discuss the emerging trends in technology standards and best practices. I'm sure that there have been a lot of value additions and takeaways from the very interesting sessions which deliberated on the importance of quality, policy, safety, security, compliance, and the role of certification in the US sector, and the desirability of concrete steps to transform India as a drone hub by 2030. Well, today we have had around 250 participants, and the conclave has been a success with such meaningful deliberations. I, on behalf of NBQP QCI, would like to express my heartfelt thanks to distinguished speakers from the Government of India, PSU, regulatory standards bodies, etc., as well as the distinguished speakers from the corporate world, etc., who have spared the valuable time to enlighten us on the conclave theme through the excellent presentations. On behalf of PAD, NBQP, I wish to extend my sincere and heartfelt gratitude to all the esteemed speakers of the inaugural session and the distinguished speakers of the technical sessions for having added value and enlightened all of us with the key deliverables on an important sector like drone, which is of global concern. So I would like to individually thank Mr. Ambad Dubey, Mr. Sripam Saurabh, Mr. Venugopal, Mr. Smith Shah, Mr. S.A. Razak, Dr. Kuldeep Singh Rana, Mr. Udit Kaul, Mr. Tulasi Raman, Mr. Ashim Datta, Mr. Anup Upadhyay, and Mr. Sai. I'm humbled for getting this opportunity to thank you all, and your contribution will be recognized by a green e-certificate. We wish to have you on more such conclaves. I would also like to thank the esteemed delegates for being with us, without which this conclave would not have been possible. I would like to extend my sincere thanks to Dr. Manish Pandey and the team members, Mr. C.S. Sharma, Mr. Guru Vayarupan S, and others for joining hands with NVQP and collaborating for such a noble cause. Last but not the least, I would also like to thank our media promotion cell, Sanjay Singh and team, and my own NVQP team, Pooja, Ashish, and Himali. Please do send your feedback as it helps us to continually improve our programs. Thank you again and wish to see you very soon. Now we may sign off. Thank you.
Thank you, Siddharth and Marshall, for continuous support. Thank you so much.
Thank you so much, ma'am. Thank you.
Thank you.
Thank you, everybody. Thank you. Did you take a photograph?
Yeah, photograph. Please ask him. Hello, sir.